I don't.
I can't sleep with headphones on.
I put my head on the table and on my. I did the night I came back from hospital.
Oh, I've got to turn that down.
Oh,
Hey.
what's that, Badu?
That's Terry's going live.
Whoop, that was a direct live.
Terry's going live.
Thanks for telling us, Terry.
Terry just went really live.
How come I don't get a notification?
I don't know. You're not special.
Oh, because you're on a flat phone.
Oh.
I got one.
Oh,
I'm
what?
special.
The Lurkinator.
I'm unsubscribing from YouTube. I don't get notifications anymore.
Yeah.
I was having breakfast and I was running a taxi service to the train station again, as usual. But I'm back.
Thank you, love.
You're welcome.
We're going to catch him one day.
Oh, we've got a spatial Casman, and we've got a
sarcastic barman.
Sarman.
I
wonder if Barman wants to come in and say good day.
Yeah, no, he can't come in yet. There's only 7 people watching. 8 people watching.
Carl said audio is brilliant.
No one's talking yet.
It's because it's all that work.
Oh, look, you guys, you take all the fun out of everything.
Oh.
Terry, we just spent 3.5 hours trying to work out your audio issue, and you're making us wait another 5 minutes before we can talk to the audience.
Good thing.
I demand sound in 5 minutes. Laugh out loud. Barman said.
Oh dear.
I was just trying to torture you, but it didn't work.
If you wanted to torture him, Terry, put up that test pattern with the audio tone.
Okay.
Oh, yeah, that one. Yeah, I'll look at that one later.
10 minutes worth of love.
If the spatial Casman is still suffering the death.
I hope he's given a dreaded lurgy to everyone else.
And I abbreviated the title for this one.
It was a tad long.
That
still gets the point across. I sent Spaceman a link.
Oh, well, he might make his way in here.
Coughing and spluttering.
Okay, it's too quiet. We've got to talk about something.
It's too quiet. Yeah.
So
can you hear us out there?
Atmosphere matters.
Why does the
atmosphere matter? I mean, the dome does it all. Oh,
well,
geez.
All right. So
Carl's back on probation.
Yeah, Carl. Look, all right, mate. I've had to go into the way back machine that is the back of my brain to find out where these pseudoscientific flat nutters have gone, and it brought me back to engineering. That a container for a gas is a sealed unit that only allows the gas to escape via a valve.
Unless
the dome does not have a valve.
Was that me?
Oh, it wasn't me.
Who's got the dingles?
I think my dingles just went off.
Dingles.
Carl, your probation officer's coming to visit you next week.
But can I ask you a question there, Demonic?
No, of course you can. I'm open to questions today.
Would it depend on the gas that you're actually carrying?
Well, there are maybe one, maybe two gases that cannot be held by a container.
Yes. Yeah, and
But
I know. For example, acetylene doesn't like being held in a container unless it's flush with a whole heap of acetone.
and that's why it has a lining inside the tank,
yeah,
because it actually absorbs the moisture that acetylene has.
yeah. Well, acetylene without that, acetylene without the acetone will actually get quite hot and go bang.
Yes, that's why when you smell acetylene, you actually smell acetone.
Yeah. Yeah,
But yeah, it actually uses a liquid, the liquid acetone in part of that membrane that they put on the inside of the tank. So when they fill it with the acetylene,
look at that.
it then mixes to change the density of the gas.
Look at that. He's got a video ready. That's what I like to see.
Okay. Let's
Oh,
go.
we're gonna shield Phil.
Let's go.
Yeah,
And
where's
Bandy, you can stop at any time if you think that he's wrong.
Okay then. At any time I can debunk it. Good to hear.
You can try to debunk it.
And then once you've debunked him, we've got him on speed dial. So we'll get him in here to debunk you after you've debunked him.
It sounds like a plan.
Because I know he's out. I know he's out there, so he's going to get another notification that we've gone live again.
Yeah, but yeah. All right,
Well,
all right. Just Bandy. Just remember what we spoke about the other night, okay? Before you attempt to debunk him.
Okay then. I'm going to say I remember, but
oh dear.
Went in one ear and out the other.
Shush, baby.
You mean there's nothing in between to stop it?
Hey, oi.
No, I wasn't
can't.
saying that. I wasn't saying that.
Are you guys looking at Bandy's video at the moment? He's saying yes, but his head's shaking no.
Nah.
All right, let's go.
You ready?
Yep, let's see.
Okay, good evening, folks. As you can see, I'm still in a hotel room in India. It's been a busy day, and I've got a couple of things on that board behind me, which I'll discuss later. Now, it seems to me there's a guy on a channel called Sleeping Warrior, who you all know about, I presume. And every time he has a brain fart, he does a video trying to debunk science. So for some reason or other, even without a science education, well, obviously, he makes out that he's better than Newton, better than Einstein, better than anybody, and these people are all wrong and he's right. Okay, all right, so we're going to have a look at a few things that he said and deal with them. Okay, well, the first thing, he starts off with some with a claim that the Earth could be a globe or it could be something else, but it's probably flat. So, and what he's saying is that we should be honest with ourselves and take the middle ground and accept that it could be a globe or it could be something else, or even flat. Well, no. It's only one thing, Mr. Riley. It's demonstrably a sphere. Now, just as a matter of example, just this last Wednesday, we launched a rocket from over here with 30 satellites on board. One of them is the Cartosat 3. The others were some nano satellites, experimental things from various countries, including the United States.
Rocket Labs.
Now, Cartosat 3 is a polar satellite, so running in a sun stationary format, or sun stationary orbit. Now, what that means, Mr. Riley, is that this satellite goes around the Earth from pole to pole, just a few degrees off. And while it's doing that, the Earth is spinning beneath it. And the purpose is for the satellite to be able to photograph the Earth, every square inch of the Earth, in 12 hours. That's how it works. This, Mr. Riley, is undeniable, and this could not work with any other configuration than the Earth is a sphere. So your assertion that it could be this or it could be that is nonsense. Okay. The next thing he did was declare that the atmosphere is a fraud. Well, you are wrong. First of all, what are you saying here? Jacques Charles is a fraud. Robert Boyle is a fraud. Guy Lussac is a fraud. Robert Dalton is a fraud. All these people have conspired to fool the public. That's your contention. Well, if you really think that you're a moron, these are some of the finest people in science. But for them, there is so much that we wouldn't know today. And one of those things is how the atmosphere works. Okay, let's have a look at some specifics. So Mr. Riley brings up the ideal gas equation, PV equals nRT, and decides to tell us that this is that PV equals nRT is just some sort of superfluous game, model that we try to look at how a gas behaves with. Well, Mr. Riley, PV equals nRT is a very, very important equation, and every part
Terry,
of it is important.
Can you just pause for a second? The professor is watching himself on your stream.
Hey, that guy looks familiar. You sure? You might be your doppelganger, Phil.
I wonder who that bloke was. Professor Phil.
Oh shit! The casual coronal ejection is in the house.
And we've got the sick man.
The casual sick man is here. Yeah.
You're getting better or worse?
Casual death.
Well, kind of sideways, if that makes any sense. I'm not really any better, but then again, I'm not really worse. I've just been to the doctor and I've got steroids and inhalers and stuff like that. So hopefully it should be better.
So drugs will help?
Yeah, drugs should hopefully help. Yeah.
Actually, you know what's really good about this stream? I've just been channel surfing and I found the Forbidden Planet.
All right.
The movie.
Oh, the movie, The Forbidden Planet. All right.
Yeah. I'm just looking at how bad it is. It's terrible.
Yeah. Extremely low budget.
Yeah, but could you imagine if they rebooted it? It'd be worse.
Well,
Yeah.
I mean, unless they made a modern version of it, it could be quite good if they made modern CGI and stuff like that. So.
Anywho, I think we should get back onto the stupid.
Yeah, I think Professor Bell wants to continue to watch himself.
Yeah.
Is that good or bad?
That's brilliant.
Oh, I better press play.
Yes, please.
Health.
In fact, we use it for extremely precise calculations and measurements. All right, so what does he say about it? First of all, he seems to be confused. He's confused about the difference between what's an ideal gas and what we call a real gas. So, what is the difference?
It seems to me he's confused about everything.
In the ideal gas equation, we're not particularly concerned about the size or the volume of a particular atom or a particular model. These things are so tiny that they are insignificant in the space that's taken up. For instance, air is 29 grams per mole. And this at 20 degrees or 293 degrees Kelvin would occupy 22.45 litres. So 25 grams of gas would be pretty insignificant in that size of volume. Do you get it? Now, real is the alternative. This is where we take into account the actual particle volume. Now, as far as atmosphere is concerned, there really isn't any significant difference that we would have to worry about. Okay, but one of the things that's very obvious, Mr. Riley, in your little discussion about PV equals nRT is that you ignore N because you don't know what moles are, and you ignore R because you don't have a clue what the gas constant is. Well, these are important variables in this equation, so they do matter. Okay. All right, so the gist of what Mr. Riley is trying to push here is that volume is that the volume is the entire universe. So he thought he was really clever by challenging us to multiply by infinity. Well, Mr. Riley, that's not that clever. You see, volume means the atmosphere. That's the gas encapsulated by gravity. the stuff that's around the Earth. Now, sure, we do lose some of it, but that is very, very insignificant compared to what's there. So the volume means the entirety of the atmosphere around the Earth, not the universe. So your argument is meaningless. Okay, so let's have a look at the board behind me. Let's discuss some of this. All right, so here we have the equation. PV equals nRT. P is the pressure. Yep, did work that out. V is the volume. You got that too. Even though you didn't understand that it means the volume held in by gravity and not the entire universe. T is the temperature. You got that. That's in Kelvin. R is the gas constant. That you didn't have a clue about. N is the number of moles. You didn't have a clue about that either, did you? Now, if we have a look at this formula, where moles is equal to PV over RT. Now, if we want to use this formula for any general gas, then we would use R, the gas constant, equals to 8.31. But if we wanted to be specific for a particular gas, then we'd use the gas constant attributed to that particular gas. So you can see it is important. Now, volume of the atmosphere doesn't change much. So yes, as I said, we would lose some, but that is so insignificant it doesn't matter compared to the rest of it. And R is the gas constant. So these two, V and R, are constants. So effectively, we can take them out of the equation. And what do we have left? That moles, the number of moles, that's the amount of the gas there in the atmosphere, is proportional to, directly proportional to the pressure and inversely proportional to the temperature. This is exactly what we observed, Mr. Riley. This is how the atmosphere works. As we go up in altitude, the temperature gets less and less. And the pressure gets less and less. That's because there are less and less molecules. Temperature is less and less because there's less and less molecules to collide with each other. Pressure is less and less because there's less molecules the higher up you go. So therefore there's less molecules weighing down, if you like. Okay. And again, this matches our observation exactly. Now, let's see what else Mr. Riley had to say. Oh yes, his little tirade on force. and mass and little g, gravity. Well, it seems that Mr. Riley is asserting that mg, that's mass times gravity, is not a force because g is not a force and m is not a force. Well, let me fill you in on this. Together, they are a force. That's how it works. This is consistent with Newton's observations, and this is also consistent with Einstein's observations. So, in terms of Einstein, mass bends space-time. Mass is required for space-time to bend. And because space-time is bent, other things in the vicinity are affected by it and drawn into the swell. That's how it works. That's how gravity happens. So this drawing of the object into the well of another, for all the world, looks to us like two objects are attracted to each other. That causes them to have a force together. F does equal to mg. Okay, where g is acceleration due to gravity. Okay. All right. What else does he say? All right. He goes on to do a quick demonstration with using Dalton's law, which is, in his mind, he thinks that he's demonstrating that that the gas will move from a low pressure area to a high pressure area, forgetting that, or perhaps he's just confused. Maybe you just confused, Mr. Riley. Atmospheric pressure is not the same as gas pressure in a container. Okay, now, one last thing I'd like to say about this. Here he is calling these people frauds and then citing their work. How does that make sense even to you? Now, my advice, stick to what you know. Science is not for you, obviously. Okay. All right, folks, I think that's enough. If you like my video, then please just press the subscribe button and I'll keep doing them. Thanks very much. Good night.
You hear that, Riley? Riley, if you're listening, science is not for you. Give it up, buddy. Give it up.
Still waiting for Bandy to debunk it.
Yeah, I was waiting for that whole time to pause it because I was waiting for Bandy to jump in with something. Nothing?
What do you reckon, Bandy?
Nothing?
I think
Nothing?
in Bandy's defence, you know, it would have been all right if there was something that Bandy could actually explain one way or the other to debunk.
No, there's no thrusty bits in this one.
That's right. If there was thrusty bits and ocky straps, he would have been fine.
Also, does anyone know why he's in India?
I do.
Oh, something to do with the rocket or something, isn't it?
It's something to do
he's
with
also
India's
helping-
space program.
Yeah, and also the new Chandra 3.
Yeah, he works with the ISRO quite a lot, which is the Indian Space Research Organization. He worked with Chandrayaan 2, the failed moon landing. He was like a problem solver to figure out what went wrong, but they all know went wrong. And I think already they're planning on Chandrayaan 2, Chandrayaan. I can't even pronounce it right. Chandrayaan
Number
3.
Number
Yeah.
3. Right, I'll
That's
get
like-
my B onto you.
Yeah, number 3. So yeah, they're starting to plan on that. So yeah,
Sorry,
sure
did I
if,
miss much?
have you
Baller,
missed
did
it all,
we-
Bandy?
You come back to life, have you?
Oh, mate,
Well-
yeah, sorry, had a phone call.
Baller, did
Oh,
we watch?
convenient.
Baller, did we watch Blue Marble Science one that you posted
No,
last
we
Monday?
haven't.
We didn't watch that one.
I don't think we did,
Don't think we did.
because today's Wednesday and I put it in there Monday and we haven't seen since.
What was that music?
Something right.
You are fantastic.
That's
at
Blue
that, Terry.
Marble's new intro.
Yeah, it's pretty flash.
Oh,
Yeah,
I
but
knew that-
actually,
I-
Blue needs to turn the volume down on that intro.
No, he
When
doesn't.
I've
It's
got-
perfect.
I've got a new intro and I've got a new outro as well, so you'll have to wait and see when I do the video next.
Does it
Oh.
involve coughing and sneezing?
You're just showing off.
Yeah, I am showing off. You're right. That's what it's all
Showing
about.
off.
I got a
we should get a
timer. I got a
preview.
timer for my intro.
And
Yay.
Terry did it himself.
Yeah.
Yeah. My outro is just me coughing, just going.
Okay, I won't be watching that then.
I got a test pattern too.
Yeah, I saw that.
You need the
Think I know
BBC
well,
one with a girl on it.
We're not in England at the moment.
I
I'm used to
wanted
test card with a girl on it.
I wanted Terry to use the old test pattern that had that lovely 1,000 hertz pitch tone over the top of it that absolutely drove every teenager mad while they were waiting for the rage with all of the local pop music to start.
I tend to agree, Russian KGB. They should have spent it on indoor
that.
plumbing.
Where did I put that one?
Do we need to take our headphones off?
Did I,
Bandy,
did
what-
I,
what-
did-
what-
did I lose
What
that one?
avatar are you, Bandy?
On the...
Oh, no lid, no pressure. I should have known.
The star.
Come on,
It's a star, isn't it, Bandy?
it is.
That's not a star. That's one of those devil worship. What do you call it? Thingy, what Bob's
Shush.
It's a pentagram, you nutter.
pentagram. That's
No,
I couldn't
it's a
say, okay. It's all right. Don't
Devil worship
shout
thing
at
of
me.
it, Bob.
It's a star. It's a star. I've got one on my flag.
Pentagram.
That bloody gleam's back again.
Okay.
Bloody
Oh,
gleam.
Whack him.
What'd you
Whack
do?
him.
Whack him.
Whack him. Hold on. There
What
it
did you
is.
do? What did I do with that one with the
Let's whack him.
that played with the
Alright.
sound?
Gleam's all right. He's okay. Gleam's okay.
I don't know. Where did you put it?
Hey,
Terry?
bye.
Oh, who whacked him out this time?
Bandy.
I did.
Bandy, you didn't get my permission.
No, I didn't.
Bandy, you just banned a flat earther.
Yeah, we
Well
tr-
done,
Banned one of your own, mate.
yeah.
We know who it is, Deb.
No, but that's not the.
No,
that's
we
not the
don't know
point.
who it is.
It's
Oh,
the
we-
fact
we
that
do,
you just
Terry.
banned
Oh, we do
someone-
not.
Yes, we do.
No, we
Yeah,
don't.
Bandy,
No,
Bandy,
we don't. No.
You
Bandy,
banned the man on
Bandy.
your side, mate.
Terry, I've dropped the link in the internal chat for you to make it a bit easier.
Yeah.
Shout
Oh,
out
did-
to sarcastic barman in the chat. Hello, barman. How are
Oh,
Yes,
you?
Barman
he's
in there.
watching. Yeah, he's out there watching.
He's watching.
Oh
him
no, I've
working.
already got blue marble.
Oh, which one did you want, Terry?
That's the test pattern one.
Oh, the test pattern one.
Terry, I thought you were all about everyone having a fair go, and yet Glenn makes one comment and then gets banned.
But I didn't time him out that time.
That's not the point. Like people in the chat are asking him questions, and he can't even bloody answer. He's got to wait 5 minutes.
Yeah, well, you can't blame Terry for that. You can't blame Terry for Bandy's actions, can you? He does whatever Bandy does.
Yeah, but like Terry has the power of spanner removal.
Yeah, but I can't do anything about it.
Terry's computer's not working at 100% at the moment.
Or
No,
you could always
yes,
give
it
a
is.
spanner to Gleam.
Copy. All right,
Gleam's
Terry.
all right. He's deluded, but he's all right. We got a similar taste in music.
There you go, Terry. There's the other test pattern that you are after. The HD one.
Mhm. Yeah, I forgot to grab it the other day off you.
That's all right.
Or have I got it? I'll just check. See if it's the same one.
Yeah, so hopefully in a few days I'll feeling a bit better. I've got some meds now. It should make me better.
You on the good meds, are you?
Meds, yeah.
Yeah, I'm on the good meds. Yeah, crack, cocaine,
No.
bit of heroin every now and again. So it's all good.
Happy days. Sounds like a nice
By the
little
way,
cocktail.
before anybody gets the wrong end of the stick, I am joking. Okay, I am not junking. Before anybody gets the wrong end of the stick, there.
The closest thing to speed is the pseudoephedrine.
That's
that's
actually
like
more methamphetamine, actually.
Well, but what you just mentioned was that's like a adrenaline, isn't it? Like a adrenaline substitute.
Sudafed used to be made out of pseudoephedrine.
Yeah, that's right. Yeah.
So then your crackheads would buy a whole thousands of boxes of the stuff and then mill it down and turn it into what's the other one? The
9 o'clock hero.
yeah, they turn it into methamphetamine.
Yes, it's actually a simple process, but I won't go into it.
Thanks, Terry.
Gee, shit.
Oh, what?
That's a beautiful sound.
My ears.
Oh, that sounds just like I've got home from a nightclub at 1 o'clock in the morning and the TV's just turned off on me.
Stop it.
Okay, might play that when we start.
Apparently, Spaceman likes bum crack.
What?
What?
Well, Sarcastic Barman goes, not a junkie, but he likes some crack.
No.
What
I
he
read
does,
that out earlier, but I was muted. Clever mate.
what he does in his own time is his own business.
What are you insinuating exactly?
I'm just saying, if you like bum crack, there's nothing wrong with that.
Well,
Why are we talking
I
about
like my
Davros, who'd you time out now?
Yeah, what did you do?
It's a frickin' sock.
It's a
Said it.
sock. Why is it a sock? How do you know it's a sock?
Peter.
All right. Peter Chris. All right.
Peter Chris.
Guess who it is? Guess who it is?
Don't know.
No, just don't talk about it. Just don't talk about it.
No.
Put it in the internal chat. Don't say.
Yeah, that's what the internal chat's for.
Okay.
I said it then.
Did you?
Oops.
Wash your mouth out, Pip Pip.
Amar Dobbin.
1996 apparently is on sub now because of that, so you shouldn't have played that stupid noise.
I don't think so.
You'll be back.
Well, we've got a
I've just unsubscribed as well now.
oh jeez.
Oh, that's fine. Two can play this game now. Where's
Get off the panel then.
Casual Spaceman on YouTube?
Anyone that up subs or whatever, they're going to get muted and they're going to lose their spanner.
No, Carl. It's night time.
Daytime, nighttime.
Sexy.
Sexy.
I've
Five
subscribed
or
again.
6 men, they looked at me and jumped on me like I was a chocolate.
Like chocolate cake.
Have to.
Yes, we have to.
Can we play Big Blue?
Yeah, we can play Big Blue. I was looking for sexy.
Blue.
No,
Let's get back to reality.
Yeah, let's play Blue.
no
I
pressure.
don't.
I've lost the sexy song.
Good.
Good.
Oh.
Good. Leave it lost.
Good.
I was sticking a few more balls on the tree.
I might be able to find it.
We're talking about the daytime, nighttime, and then Pip comes in going, I'm putting more balls on the tree.
Yeah, well, Super Rats, watch out.
Have you not got enough balls in your life, Pip?
I was about to say, watch out, Super Rats. Here comes Pip. She's after more balls.
Super Rats has no balls?
Oh, not if Pip gets to him, but apparently so.
It better be the bird one. Last time I had nightmares. Is there a bird one?
Yeah, remember the one,
Oh, the daytime, nighttime one.
the daytime, nighttime game with the bird.
Yeah.
Mm.
Yeah, but that's part of a whole video of different ones, though, isn't it, with animals speaking
Yeah.
and that.
Oh, we'll listen to Blue for a little while.
Just make sure you have the volume down for his intro, or people might get angry.
Will they?
Well, because it comes out loud over YouTube, buddy.
He's somewhat very quick.
So when you're talking and I press play. I like it loud.
Hello, everybody. Welcome to Blue Marble Science.
Hi.
I bet you guys didn't know gas doesn't have weight because it doesn't have mass, did you? Say what? Oh boy.
Air has mass, therefore it has weight. Yeah, but there's no intermolecular bonding between each particle, is there? Weigh a balloon, inflate it, weigh it again, it'll be heavier. Do you now accept air has weight? No. The only weight that you can get away with is mass times little g. Well, we'll give you little g just for shits and giggles, but what mass have you got? You haven't got any mass. You haven't got any intermolecular bonds to create a mass. You've got molecules devoid of any mass because there isn't any mass. It's basically zero. You haven't got any intermolecular bonds to create a plug. So how is the atmosphere creating a plug effect, a container? It can't, can it? It's not a solid, it's a gas.
Yep, it's going to be one of those days. Warning, severe facial and monitor damage alert is in effect. Get out those oven mitts. Push the monitors back out of punching range. And Gladys, this is going to be one hell of a dumpster fire.
If you're honest about it, this discussion, the flat earth discussion, is basically an argument of equivalence. If you're really honest with yourself, you'll realise that a lot of the evidences go either way. You're in the middle. One side, it's a ball. The other side, it's not a ball. Might not be flat. It probably is flat, but it could be something else too. But the equivalence principle is that you can see it one way and you can also see it the other way. Obviously, Einstein uses it to explain how you would feel the effects of gravity if we were stationary. It would be a downward force, and you wouldn't be able to tell the difference if we were upwards accelerating at 9.8 meters per second squared, or whatever it is. The equivalence principle is you can't tell the difference between the two. If you're intellectually honest with yourself, you'll realise that this is what this topic is. It is a discussion of equivalence. It's intellectual. You do have to have a certain amount of critical thought. You do have to have a certain amount of cross-referencing different elements to see what works and what doesn't work. And I'm often asked, what's your strongest proof? This is by flat earthers as well as ball earthers. What's your strongest proof for you? And for me, it's always been gravity. The minute Einstein said gravity was an effect, then that changes everything for me. That was like the strongest one. But this is probably the most easy to understand, obvious to contrast, and powerful argument in all my time on this discussion that I've come across. Let's talk about the fraud that is atmospheric
Anthony Riley.
pressure.
Okay, Anthony, what was the purpose of putting the definition of the word equivalence up if you weren't going to go by the definition of the word? Equivalence, the condition of being equal or equivalent in value, worth, function, etc. You skipped completely over that and went straight to the definition of the Einstein equivalence principle. That's not what we're talking about, Anthony. This is what you're mad about. We're calling you guys out on this. This is a false equivalence fallacy. You guys continually try to make pressurized gas be exactly equal to atmospheric pressure, and it's not. Pressurized gas is like gauge pressure. That is pressure in excess of atmospheric pressure. And the way you get it is by a very different mechanism than the way atmospheric pressure, which is actually absolute pressure, occurs. That is the false equivalence fallacy. That's another fail. So move on to your gish gallop about a pressure simulator, Anthony.
So let's have a look. It says the ideal gases. The ideal gas, or perfect gas, is the theoretical substance that helps establish the relationship of four gas variables: pressure, volume, the amount of gas, and the temperature. So it's PVNT, right? It's the relationship between pressure, volume, gas, and temperature. Now, this is the key bit, because you have to have the volume, right? So if I go, what happens if we multiply by infinity?
You're going to put a question mark at the end of this?
What happens if we multiply by infinity? If any number is multiplied by infinity, then what will be the answer? Infinity means a number still larger than whatever we can think of. It is therefore obvious that addition and subtraction of a finite number...
Is there the only person I know of that puts a question mark next to a question?
What, in Google?
Yeah, in Google, yeah.
Yeah, in Google, I know. It's funny.
He's asking a question, but he put...
I must admit, I do that as well, because it used to be, what was that thing you had a search engine where you had to ask a question? It was Ask Jeeves, wasn't it? That's where I get it from.
So Riley's not the only one.
No, sadly not. I'm just as bad, I'm afraid.
I'm glad you admitted it.
Well, you know, at least I'm honest.
From infinity will have no impact on it, and it will still be infinity. It's the same for multiplication and division. If you multiply or divide by anything to do with infinity, it's always going to give you an infinite answer, infinity.
Division by infinity is not infinity, Anthony. Division by infinity equals 0.
Bear that in mind, because they tell us that space is an infinite vacuum. So straight away, if the volume is infinite and you're multiplying by infinity, the volume being infinite, we're going to see what happens when we play around with a gas simulator. Now, here is a link from
we have watched this before,
and this is demonstrating the relationship between the four factors that we just looked at. So we've got pressure, volume, the amount of gas, and temperature. If you have a nice handy simulator that you can play around with, you can see that obviously there is a container. And in this example, we've got the volume that we can play with, we've got the temperature that we can play with, we've got the amount of gas going in that we can play with, And we can play around with all the variables. Oh, and heat. We can play around with the heat. So this is the actual like simulation of pressure, volume, gas, temperature, and you can play around with it. So let's look at it here. So this is the way it's set up at the minute, right? We've got this is nominal values. They put in whatever, doesn't matter. All these numbers are all relative to each other. This is why I say it doesn't matter what these values are. They're relative to each other. They're relative numbers. So it doesn't matter what the scales are. It doesn't matter whether they're realistic or not. They're relative numbers. If you understand how relative numbers works, then you'll understand that these values are pretty much meaningless. They relate to each other. They don't relate to an absolute position, okay? So what we can see is we've got some gas and it's inside this container. Bear in mind that they tell us we live on an Earth that is infinitely in the vacuum of space, right? That is the definition, and that's the best demonstration that I can find for a gas pressure simulator. So let's apply it to Earth. Gas pressure simulator. Oops. Simulate, and then we'll go to Metabunk. Now he's got one in the gas. So what we'll try and do, here's the simulator. So you click on it. And we've played with this before. Planet, temperature. Right, so first off, you have to knock off the gravity because we know gravity is in effect. And we know that the temperature varies, but it's really cold in space, but there's a massive differential between the vacuum of space temperature and our temperature. So we can basically turn that up, and basically it's not.
Where's all the atmosphere gone?
Because we know what happens. We know the fact is the atmosphere is a lot warmer than it is in space. But that's what happens on their model.
No, Anthony, that's not what happens on our model. What happens on our model is the pressure gradient that we observe. We can predict it pretty accurately with a barometric formula. Now, if you have found a way to turn off gravity, as you did in the simulator, please share that with the rest of us. That would be a handy thing to have. Right now, I don't believe you can do it.
Weight's defined as mass times little g. Little g isn't a force, so what are you multiplying? Fuck all? Nobody said little g is a force. Well, actually, you all say it's a force. It's acceleration. Right, so if a mass accelerates, then it's a force. Something's doing that, because by virtue of F equals ma, if you got an accelerated mass, you have a force. An acceleration is a scalar.
Is acceleration a vector or a scalar? Type it into Google search, Anthony. Acceleration is a vector quantity and not a scalar because it has both magnitude and direction. How many years have you been masquerading as somebody that knows something about science and you still don't know the difference in scalars and vectors?
Then he says the weight of the atmosphere prevents it being sucked up into space. Well, how many times have they told us that atmospheres don't suck, vacuums don't suck? But now here he is telling me that the weight of the atmosphere prevents it being sucked up into space. Well, we're saying it's being burst into space because of the pressure. But now he's saying the weight of the atmosphere prevents it from being burst into space. And anyone who disagrees is admitting to being a retarded clown. The weight of the atmosphere. Okay, so we need to look at where weight comes into this. How does the atmosphere... So I said back, how does the atmosphere have weight exactly? Do you realise gases do not have intermolecular bonds? Their mass is limited to the molecule mass. Basically, it's a massless particle. It's the size of a pinhead. It's tiny. Its mass is tiny. Most gases are extremely light. They have virtually zero mass.
Right,
it isn't
hang on.
zero,
This is where he's...
but you can think of it as...
First of all, he's saying it has no mass, and then he's saying it virtually doesn't have any mass. So which is it?
There has to be one or the other.
It does or it doesn't. It has to be one or the other, Riley. Is it going to be one or the other? You can't have both ways. So it either has mass or it doesn't. Make up your mind, pal. Virtually. Okay, it might be small. It doesn't really matter. If it's absolutely minute, it still has mass. Oh, God.
Is zero, because it's that small that it basically has no mass. There is no intermolecular bonding between each particle, each gas molecule. So if gravity is a force, it's not pulling the atmosphere down. If gravity is a force, it's pulling the individual molecules down. But we know it's proportionate to its mass. But if the mass is basically zero, then what is it doing? If the mass molecule is basically zero, and we know that it's a 50 millionth according to the quantification in Cavendish, that they claim I always get wrong, but I don't get wrong. They just refuse to accept that I'm right.
You're misrepresenting it again, Anthony. The Cavendish experiment used 2 lead weights, a small one of about 1 kilogram, a large one of about 150 kilograms. He was measuring the attractive force between the lead weights, and it was about 1/50 millionth of a kilogram. The small weight still weighed 1 kilogram. The large weight weighed 150 kilograms. You need to stop misrepresenting this.
What is gravity pulling down? How is the gravity pulling down the atmosphere when you only have one molecule that it can act on? It can't act on the atmosphere as like a plug. It's acting on each individual molecule, but that force is minuscule and the mass is minuscule. So what are we dealing with? Air has mass, therefore it has weight. Yeah, but there's no intermolecular bonding between each particle, is there?
Terry?
Weigh a balloon, inflate it.
Professor Phil would like to join. I think he needs a new link.
I sent him a link.
Was it from this stream? Or the stream before? Or the stream before that?
No, I sent him a new link in the DM Discord.
Yeah. Check your DMs, Professor.
It's the last one I posted in your DM.
Yeah, that Gleam character's stirring shit up again. Yeah, we even called you out, Bandy.
Called me? What?
Yeah.
What? It called me out?
Oh shit! We got Bandy's triggered now. Look out! Step back.
Where are we? I'm gonna go back.
Move out of the way.
Benzel Bandit, why you tie me out? You didn't even answer him. Oh, nice.
Yeah. How rude.
Look, I'm sorry, Gleam. I got trigger happy. My bad.
I have to stop sharing for a sec.
Is that twice you've timed him out now, Bandy?
No, I've only done it once, and Terry's done it once.
Oh, right.
Yeah, tonight. Who have I? No, I just that Gleam character. I was.
Yeah, same one. It's the same one, Terry.
There you are, Phil. I just posted the same link again in a DM in Discord.
I don't think that Gleam character is the same Gleam that I'm thinking of. I don't think he's the same one.
Are you sure?
Yeah,
I don't think it is the same one that you're talking about, Casual.
Yeah, he might be an unsavoury character. I have to keep an eye on him.
Yeah, so if it's not the one I'm talking about, do whatever you want.
Well, actually, you should be careful, Casual. He might be smarter than the Gleam you're thinking of.
Yeah,
as long as he behaves himself, I won't time him out.
Oh, okay. So just tell me when you want me to time him out then, Terry.
Well, you said the conditions have to be right?
Alan's back.
But also,
sorry about that. It's
sarcastic is having a bit of backwards and forwards too.
Sarcastic Barman, what you actually meant to say was, why do things go down? Why do they go in the direction that they're supposed to do? It's all to do with buoyancy and equilibrium and all the rest of it.
Don't give him a heads up, Casual. Stop helping him.
Professor Phil, if you click on the link without the, what happens when you press on the link for the Zoom if you haven't got the app installed on your computer?
It goes through Google.
Google Chrome.
Yeah.
It'll go straight through Google Chrome.
Andy,
Oh.
I hope you do know I'm not a flat earther, you know.
Not yet, you're not.
You have to.
Yeah.
Otherwise, you have to
always
download the. Otherwise, you have to download the app by googling Zoom, and it'll come up to download from there. You download it from Google.
It's in Discord at the moment.
I'm sure Professor Phil's got the Zoom app installed because we did
he
it the other
has.
night, didn't we?
That's correct.
Well, if he's got the app already installed, once you click on the.
You should just click the link.
He said in the chat earlier on that he was waiting to go into a meeting.
Yeah.
He's had his meeting. Okay.
Oh,
he
is he?
asked if he could rejoin. He
All
says,
right,
"I
don't
click."
shout at me.
Oh, that's it, casual. That's it. I'm going to treat you like I did bloody.
That's all right, casual. I'll come in and bat for you. Demonic, leave him alone. Back off.
I'm sick.
Look, he's a sick man. He's a sick man.
I'm a very sensitive boy. I'm a very sensitive boy.
Yeah.
It's all right,
I'm going to
casual.
get all Slick James on.
Picking on a sick man. Jeez, how low.
It's all right, casual. We'll look after you.
Have you
I
got
bet you used to pick on the kids with the glasses in the playground, didn't you? Yeah, knock them in the face when they're wearing glasses. Yeah.
Depends if they had crutches.
Hey, I was one of those kids.
Casual.
What, they used to pick on kids with glasses?
No, I was the one with the glasses.
Yeah.
I mean, I am the one with the glasses. Sorry.
But for part of my school life, I was walking around with casts on both legs.
Yeah, see, that's why you pick on kids with crutches, because you know you can outrun them.
Yeah, but when I was in year 6 and I had the little rubber soles on the bottom of my casts.
Oh, I hate those.
No, but it was the fact that I could walk with my casts. I didn't need crutches, which means I could kick you and it wouldn't hurt me.
Did you ever have your little rubber stopper fall out?
Yeah, it happened twice.
And then you piff it at someone from the other side of the room, and it bounces off the head so well.
No, I can't post the link in the YouTube chat. Sorry, Phil.
I'll sort him out in Discord, Terry. Just give me a moment.
I DM'd him a link.
Everybody's timing out everybody now. I get it.
Hey, what are they doing out there?
And I get it was timed out by bands.
Oh dear.
Bandy,
You're getting a bit whack happy out there.
You know, Bandy keeps timing out the people that are on his bloody side.
No, I
only
timed that fellow out and Dinky because of what he said. Was inappropriate. I'm sorry.
Bandy, you've been timed out though. I get it timed you out. Oh no, it's the other way around. Sorry, you timed. I get it. Yeah. Sorry, I got it wrong around. My bad.
Actually, Dinky, Bandy, and Carl have all timed out for 300 seconds.
But now Carl Edwards is timed out. I get it.
Yeah. Well, because he wanted Terry to play with something.
Yes. No, that deserved it.
Who can I time
out? Gleam.
Who can I time out just for the laugh?
You can time me out if you want.
I can't time out any mods, can I?
No.
I can.
It's a laugh.
I can, Spaceman.
I can. Oh no, you can. I wanted to time out Sarcastic Barman. I wanted to time out Sarcastic Barman just for the laugh.
We've got a special guest in the house, a Professor Philip Bell.
He made it, did he?
Yes, he made it.
Lovely.
The professor has landed.
The professor has landed. We can allow the professor not to have an avatar. That's okay.
He's special.
But the thing is though, is this a successful landing though, Professor Phil?
It looks like it could be.
Not that I'm hinting at anything.
We'll have to wait till he gets his mic up and everything, and we'll see.
Casual.
I just said we have to wait till he gets his mic up.
Casual, you realise that.
Davros, that was a hint.
Mistakes.
Hello, testing.
Who was talking to me? What?
I'm saying we're waiting for Professor Phil to get his mic up.
Yeah, we know. Who was talking to me just then? Somebody was mentioning
That's
my
why
name.
I said hint, hint. You can't talk while somebody else is waiting to get their mic up. Testing, testing, Phil. If you can hear us, we can't hear you.
Okay.
Yes, we can
better.
now. That's better.
All right, can you hear me?
Yes, we can hear you loud and clear, Phil.
Oh, mute. So there we go. Now let's get back to where we were before. I
Okay.
just about chewed my arm off after I heard Riley say something. So what did he say? The gas hasn't got any weight. The gas has got no mass. Is that what he said?
Yeah.
All right. Professor, just to bring you up to speed, because there is no intermolecular bonds, which they're actually intramolecular bonds. That way, molecules do not have mass because they don't have any bonds to create the mass.
And I don't think he can make up his mind either, because one minute he says it has no mass, and then it says it's virtually no mass because it's so small.
Now it's getting a bit
confusing
confusing over here. The gas has got no mass. Is that what he said?
Have you got the live stream going, Philip?
I must have. What do I have to turn off?
The live stream.
Yeah,
just turn the
just
sound.
mute
Yeah,
YouTube,
just turn the
mate.
sound off the live stream.
Yeah, just mute the live stream.
No, not you. The live stream. The YouTube live stream. Now you got to unmute yourself.
Unmute yourself on Zoom.
Yeah.
There he goes.
Well, I can't do that.
No.
If you just mute yourself from your end, I can't unmute yourself from my end.
No, you can just request it.
Hello.
Hello.
Yeah, I know it was very eerily quiet.
Philip can't unmute himself back in Zoom.
Oh, can't he?
No, he's muted himself and now he can't unmute himself.
Bandy's fault.
Must be.
Yeah, always blame Bandy.
How do you unmute yourself? You have to go to your participants.
Yeah, no, you should be able to go down to the bottom left-hand corner, and there'll be a picture of a microphone.
Yeah.
His will have a line in it going from the bottom left up to the top right. He needs to click on it once. If that doesn't work, he needs to click down on the bottom, click where it says participants, so it comes up as a side screen. Once that happens, go up to his name, which should be at the very top, highlight his name, and he should be able to click on the unmute button that comes next to his name.
Yeah, what he said.
We'll just have to listen to the video for an hour.
You might have to drop and come back in, Eric.
What are we dealing with? Air has mass, therefore it has weight. Yeah, but there's no intermolecular bonding between each particle, is there? Weigh a balloon, inflate it, weigh it again, it'll be heavier. Do you now accept Earth has weight? No. The only weight that you can get away with is mass times little g. Well, we'll give you little g just for shits and giggles, but what mass have you got? You haven't got any mass. You haven't got any intermolecular bonds to create a mass.
Anthony, you couldn't have gotten more things wrong than you just did. What on earth would intermolecular bonds have to do with the mass of molecules? Oh, never mind. Thanks for watching, folks. I hope you enjoyed it. It's worn me out. If you did, don't forget to hit the like and subscribe buttons. There's a link to the Patreon account. You can find it up in the comments section too. And we'll catch you guys on the next one. Hey, Gladys. We're out of here.
So,
Okay,
is Riley suggested that H2O water doesn't have any intermolecular bonds between
That
hydrogen
sounds like it's what he's
and
saying.
atoms?
Yeah. Can we just clarify? It's intramolecular between the molecule, and then it's intermolecular between that molecule and the next.
Well, he said intermolecular.
Yeah.
Phil, you got to figure out how to mute the video
Yeah.
live stream of YouTube.
Okay, all right. Yeah, exactly, and that's the thing that I've got no idea how to bloody do. So
Are you on a laptop or on a phone?
I'm on a laptop, and I've got
Just clarify. It's intramolecular between the molecule. Just click on the video on the laptop for YouTube and
Yeah, I've got
lower
that.
the volume.
Yeah, okay. All right, I've got the volume off.
There you go.
Right, there you go.
That's it.
Okay, all right.
Now you're
so you
cooking.
can hear me now. Good.
Yes, we can hear you without the YouTube
all right.
thing.
So okay, now so I'll just stop chewing on my arm after rubbish. So I was going to suggest that that Riley freeze some carbon dioxide into a kilogram block, and drop it on his foot.
Yeah, I saw that in the chat. That was quite funny. Yeah.
Yeah, drop some dry ice on your foot and tell me it has no mass. Yes.
Yeah, something like that. A kilo of it'll do. Yeah.
Or even
No,
some,
actually, do you remember Abbott?
Yes.
He's the one who came up with that. Abbott went on and said that carbon dioxide has got no mass, no weight. So I wrote something on the Liberal Facebook, and I told him to go and drop some ice on his foot and see what happens.
Yeah, but the Floafer's usual argument is you brought it up from its resting place or something to do with it.
Yeah.
To do with a mass or something.
Yeah. So I'm not sure. So he's so Riley's basically saying that for some reason or other, it's so tiny that it can't have mass. Well, exactly what does he think everything is made of? Isn't everything made of tiny particles we call atoms?
Yep.
So how can anything have mass if none of the atoms have mass? How does that not register in his mind?
Oh, somehow he's made a connection between the whole gaseous particles don't necessarily have to stay next to each other and they can move around freely in space.
Yeah.
To they no longer have mass.
I also don't understand. I don't understand where he gets this. There's no intermolecular bond between the atoms, between the particles. Where did he get that from?
Yeah, well, why wouldn't there be? I mean,
yeah, exactly. I mean, but quite often, you get these arguments and stuff like they're usually based on something, but I don't even understand where he even gets that from.
No, well, he just made it up by the sound of things.
I only know of two particles that have no mass.
Well, photons, yes.
And neutrinos.
Yeah. Well.
Yeah, they have energy but no mass.
Yeah, exactly. Well, it's so infinitely small mass anyway for have any mass at all. But yes, they're all energy. Yeah, well, photons are a prime example of that.
Yes, but our atoms are not photons.
No, well, then we wouldn't have any because we're all an accumulation of all these atoms. So where did the mass come from? If none of the individual atoms have mass, where did the mass come from?
Well, because you see, if the particles have mass, or the molecules have mass, he has to admit to gravity.
Exactly, he does, and that's the big issue. So I think what he doesn't understand is he's one of these guys. He goes around and thinks that he's found something, an aha moment, but doesn't follow it through to try and understand exactly what it's telling him. So I've tried to explain this before, and I'm not sure that they got this. And that let's just start with the smallest atom. It's got one proton, one single proton in the smallest atom, which is hydrogen. Well, if I was managed to grab and smash together 6 protons, I'd have carbon. I'd have a lump of carbon. If I could smash together 8 protons, I'd have an atom of oxygen. The protons are all protons. They're all the same stuff. And if you have a mole of these protons, you've got a gram. So we know exactly what things are. Their mass is going to be how many protons they have. That's where it all starts. We know from the proton how much it is. If I have 1 mole of oxygen, it's going to weigh 16 grams. Absolutely. If I have 1 mole of air, which is oxygen and nitrogen mainly, it's going to weigh 20 grams. Exactly what's going to weigh. So,
bugger.
And how much you get in a mole, volume-wise, well, that depends on how hot it is and how high up you are. If you're really high, like nearly in space, wow, it'll take a bloody lot of space to make 18 grams of 16 grams of oxygen, or even 1 gram of hydrogen, because there's so few molecules around. But I mean, gravity holds down these molecules because they got mass.
I know you might have covered it, but Ozzie Org says, why does the mole formula work?
Yeah. Oh, well, I tell you what, there have been some bright people, some bright humans on this planet, and none so bright as this guy called Avogadro. And this Avogadro worked out, he's the one who worked out that if you get 602 by 10 to the 23 atoms together of oxygen, it will weigh exactly 16 grams. So you looked at that and said, wow, what about nitrogen? What about fluorine? And then guess what? We've got the periodic table. We know exactly for every single element how much 6.02 by 10 to the 23 atoms of that element will weigh. So now we can predict on just about anything. So I want to make hydrogen. I know exactly how much I need of this. I know exactly how much I need of that. I can make. So if I want to make ammonia, I know exactly how much nitrogen and hydrogen I need. Put them together. Bang, I've got ammonia. That's called the Haber process. I can predict exactly what I need and exactly what I'm going to get because of this guy called Avogadro. That's just brilliant. Now you think about these people that did that. So this guy Avogadro and Mendeleev, the guy who put the periodic table together, this guy had 20 elements to work with. That's all he had. And he derived the entire periodic table from 20 elements. That is just absolute genius.
Yeah, Phil, didn't it only go as far as iron?
Yes, it was, but not only that, it wasn't as though it went, he had them in any kind of order. He had one here, one there, one there, one there. And they had all the spaces in between. And then basically said to the rest of the scientific community, here you are, here's the table, you go fill it. Because now I've told you exactly what they're going to look like. I've told you exactly what they're going to weigh and exactly how they're going to behave. So everybody else said, wow, and then they just went nuts getting their Nobel Prizes on the back of this guy. That's what happened. So they weren't geniuses who came up with the elements. It was the genius who came up with the periodic table. That was the real genius.
Yeah, but you see that lovely Fe element there?
Yes.
All right.
Yep.
That is the as far as I understand, it is the best complex carbon set of molecules that they had at the time.
Well, I mean, that came all the way back from the Stone Age. So they understood how that thing, how iron worked. And iron is still a very, very interesting element because it's, I mean, half of Western Australia is made out of it.
Yeah, so's Iron Knob here in South Australia.
Yeah. No,
the mountain is red from rust.
Exactly. Yeah. But the beauty thing about iron is that it's one of those few elements that can actually, in its natural state, will be magnetic. So the iron oxide Fe3O4 is actually called magnetite.
Yeah,
and it's because it's naturally magnetic. The crystalline structures line up perfectly, and that's what makes it magnetic. And the thing about it is the whole surface of the Kimberley is practically made out of this stuff. Yeah, so Anthony, the thing about Anthony, what makes me a bit triggers me about with him is he says this bullshit with such bloody arrogance and confidence.
Snake oil.
Yeah, I know, but it's kind of like he believes it. I don't know whether he does or not anymore. Confused.
My thinking is the reason why he's doing it is because he wants to be seen as some kind of guy that kind of is challenging the scientific world. I mean, he has no qualification in any kind of science whatsoever, nothing. Yet he believes that he's actually debunking real scientists, and professors like yourself.
Yeah.
He really believes that he's doing it. Well, he might. Maybe he doesn't actually believe it, but he's trying to portray to people that he's doing that. I'm not sure he believes.
Yeah.
I really don't. I'm not really sure. I'm not really sure whether he believes the Earth is flat. Really, to be honest with you, I really don't.
I don't think he did, because I've pulled him up a few times and asked him flat out. I said, "Do you think the Earth is flat?" And he goes, "Well, it could be this and it could be that." And he goes, "Well, if you're honest with yourself, then you'll say you don't know." Well, bullshit. We do know. It's freaking the sphere. Otherwise, we wouldn't be able to get the satellites around it. I mean, how is that?
Yeah, and my radars wouldn't work the way they
so
do.
Stupid. It's so stupid. I can't believe it.
To a certain extent, this is going to sound a bit of a strange thing for me to say, to be honest with you, Professor, but you being the person that you are and the qualifications you are and the things that you actually do, to a certain extent, you're actually kind of wasting your time, getting into sort of anti-flat Earth. And not that I'm trying to turn you away from it, but the problem is, you see, then it doesn't matter whether somebody's. I mean, we could actually put Einstein on a live stream.
Yeah,
if he was alive, right? And it wouldn't make a blind bit of difference because they won't accept anything you actually say because it doesn't fit the narrative. But the way I kind of see it is that the reason why a lot of have these debates and things like that is not to convince the person the flat earther that the Earth is, we live on a globe. It's the people that are listening. That's the most important people.
Yeah, exactly.
And also children as well. I mean, that's one of my greatest motivators to be involved, is because I don't want my children's education to be ruined. Because that's what they're trying to do. They're trying to push it into mainstream education as well. And I couldn't possibly allow that. Father to young children.
Look, if it ever got into a school, it would have to be one of those alternative schools, and they've managed to talk some some flat Earth principle into doing it. That's the only way. He could not get into a mainstream school. It's just impossible.
Well, not in a mainstream, but I mean, it's happened in America because they don't have a. I don't think they have a set curriculum. I could be wrong.
Yeah.
But I don't think they have a set curriculum. So they, you have some schools can pretty much teach whatever they want.
Yeah.
So if it's along the religious lines, then they potentially they could do.
Oh, we have a little bit of inside information in the chat. From Lovable C4, SW told me he wasn't a flat earther. I'm not sure if he was messing with me. I took screenshots anyways.
So who's C4? Oh, I see.
Sleeping Warrior.
Ah.
No. C4 is.
Oh, C4 is.
C4 is
a person.
He's a constant.
A normal person.
Yeah, he's definitely constant.
Okay, a normal person. Yeah. Okay.
Yeah.
Okay. All right. And he has it on good authority that Anthony's not a flat earther.
Well, he stated as much in a conversation, and he got screenshots of it.
Yeah.
You're definitely going to have to.
I do have a sound recording. Sorry.
Yeah. Go ahead.
I do have a sound recording of Anthony Riley admitting that his what was it? His
okay,
relative density disequilibrium had to have gravity for.
You have to have gravity for buoyancy to work.
Yeah. Because he was talking about siphoning, and one of the defences I've heard was when he was tired.
Anthony, you do. Yeah. Because it's in the formula. If you want to calculate the draft of a ship, try and do that without gravity.
Yeah. But the silly thing was, I saw somebody else try and defend him.
Yeah.
In a side chat when this clip was played, by saying, "Well, he sounds tired, so he must have been tired. So it was just a slip of the tongue."
Yeah,
when you're tired, it was because when you're tired, it's so much harder to lie.
Yeah, it's a slip of the brain, more like it.
And he would have had to have actually went through a thought process to actually say that to begin with.
Yeah,
so he must have actually thought about gravity actually working.
There's a reason. There's a reason why back when during the war and all of that the Americans, the Department of Defense in America actually introduced sleep deprivation to enemy soldiers because when they're tired, they're more likely to slip up. They're more likely to actually say something they're not meant to say. That's right. Have a Freudian slip.
Yeah.
So just the fact that he was tired.
Serum has a lot of that kind of effect on you. So I don't know if you know about the truth serum, that forces you to tell the truth.
Yeah.
Well, sodium pentothal
cuts down any inhibitions that you have, and so you not only tell the truth, but you act like an idiot as well. But yeah, you can't. You basically your mind isn't sharp enough to be able to work out why they're asking you certain questions. The easiest thing you can do is just tell the truth. That's basically how they work.
Could you imagine if you were able to slip some sodium pentothal into Riley's drink?
Yeah.
He'd feed it to his dog.
No, that would be secondhand though, wouldn't it?
Yeah.
Oh, yeah.
Yep, that's the stuff, sodium pentothal. Yep.
Yeah. But here's the thing, okay, and one of our friends in chat, Niels brought it up, was about the Riley Oakley back chat from one of their streams when Nathan Oakley talks about perfect evidence of the globe. Talking about a lighthouse and that it can be seen from, I think it was 26 miles away, blah, 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 from the height that it was at. But it's the fact that you had to be at the particular height on the ship to be able to see it, and that was perfect evidence of globe proof.
Yeah. So yeah. So So this is what I don't understand, why they don't get this simple thing. If you see an horizon, that is proof. That is absolute evidence that what you're looking at cannot be flat. I'm not saying it's got to be round because you can't see, but it certainly can't be flat. Because if it was flat, everything would be small with the same perspective. You'd be looking out, and no matter what you looked at, got smaller and smaller and smaller, and it just will reach the vanishing point. You won't be able to see it anymore. But there's no way known you would see a ship in its entirety 6 feet below the water. That would be just impossible. Why can't they get this?
Again,
Everything would go smaller and smaller and smaller, and that's not what happens. The ship just seems to like it's sunk. You know, you can see the blades even still turning. If you look at it, you can actually see there. You can't see the stem of the windmill or the turbine, but you can see the blades still out there. You know, beyond the horizon. Well, how can you do that? If it was far enough away, why wouldn't it be even so tiny that you can't see it? Why is it the blades are still large enough to see, but the rest of it, you can't see it? How can this even make sense to these people? Staggered.
You're not the only one, and that's why I don't. The moment they come out with perspective, I ask them, do they know how to draw perspective?
Yeah.
Ether band.
No. I've debunked it. I've got the picture.
Ether band.
No, I've debunked it. Where's my
Ether
picture?
bunny.
Ether bunny.
There you
Ether
go.
bunny.
Debunked. This is your ether, okay? Also called the quintessence. It's a material that fills the region of the universe above the terrestrial sphere. Okay? That was it. And that's direct from Greek.
Yeah, but ether band.
I've got the ether band. Can't you see them underneath? And look,
Yeah, but
they're all
it's
thinking globe.
bandits from the bit from my eyelid to the point that I'm looking at. Don't you know that? Come on.
No. But look, I've already got the ether band. Can't you see them? Can you see them?
I think that was you that said that, wasn't it, Bandy? It was a bit, the ether band was a bit between underneath my eyelids to the point I was looking at.
And everything in between.
And everything in between, yeah.
Yeah, also, Professor, are you still there?
Yeah, I'm just listening to you guys.
Okay, can you see the picture I've got up?
Okay, so I've got ether. Is that right?
No. There'll be another one coming up in a second. Hang on.
Yeah,
Still
don't
wait
look.
for
Don't
YouTube to
look
catch
at the. Don't look at the YouTube.
Okay. I'll look at the other one. All right. Yeah.
Yeah,
have a look at the
Zoom. Yeah, use the Zoom for looking.
Yeah, but
okay. All right.
Okay, this is the representation of acetylene. Okay.
Oh yes, I see that down there. Yeah, I'm looking at the YouTube, but I don't know.
No, you shouldn't look at the YouTube.
Oh well, don't
I can see
confuse them.
I can see the acetylene. It's so this is an alkene.
Yep.
And in fact, it's the first alkene. Yeah.
Yeah. So what Riley thinks is, see, the sticks that hold these molecules in place. He thinks these are the bonds.
Oh wow. Okay. So he thinks they actually like these sticks.
Yeah. He doesn't realize that they're actually all right next to each other.
Yeah.
Yeah. So he doesn't
okay.
understand C2H2.
Yeah.
Right. It means that you've got two of this one and two of that one, and they combine to create an element.
Yes. Yeah. Exactly.
Yeah.
It's literally. Yep.
Yeah. But this is his fall down, is because he thinks the fact that you guys use people in chemistry use sticks to show.
For and about the intermolecular bonds. So I wonder how he thinks water becomes a liquid after it's a gas. If you don't have that sort of bonding.
The magic screaming pixies come down and stitch it all back together again.
Wow. Amazing.
pixies, it's fairies.
No, it's
I
magic
thought-
screaming pixies.
I thought the pixies do the dance to make electricity, and it's the electromagnetic effect, so that makes it electricity that joins it all back together.
I've never seen a molecular bonding structure for unicorn farts.
No, but there probably will be one. It's probably methane, is it? CH4. Yeah.
Yeah, probably.
Oh God.
Yeah, but I still say it's not. I still say it's fairies, not penguins.
Yeah. I'm just thinking, what do you reckon about this? Do you reckon like he knows what the hell's going on, and he's just searching for ways that he could fool other people? In other words, these people can't be smart enough to know this.
You have a look at you have a look at a lot of the statements he makes, and he's always chosen an argument that could be easily confused and or confusing to someone that doesn't understand physics, chemistry, or math. He always makes sure that the whatever subject he's picked up, and I'll use the egg experiment that he did, for example.
Yeah.
And I said example there because I know Terry likes it. I'll use the word deception to show that he was creating that egg to float up. That he was the one that was controlling it, not gravity. Gravity's got nothing to do with it. So a lot of the stuff that he's done, he's misinterpreted, in my opinion, on purpose.
Yeah.
Or he's deceived people willingly with, I'll use it, common party tricks.
Yeah.
But
that's it. I think you've nailed it. That's it. So he's trying to use this sleight of hand, which is kind of watch this move, and now I'll give you an explanation for move, which of course his explanation is total bullshit. But they don't know that. They're just focusing on the fact that it moved. If he made it move, he must know why it moved. So that's why they trust him.
What I love is hearing a science educator say that something is bullshit. Oh, it's brilliant, because we say it all the time, but they don't listen. But then I hear it come from you, and I go, oh, so we're not the only ones that say it to them.
No. You want to hear some of the students come out with stuff when they want to say bullshit. They're not so kind. Yeah, but go on.
No, there's a thing as well about that egg experiment. I mean, he bangs on about the scientific method all the time, and the fact that he calls pseudoscientists don't use the scientific method. They're not doing any science. But then he does a so-called experiment. He uses a device that he doesn't. He admitted himself on the actual stream that he didn't know what it does. Yeah. Okay. He also said it produced figures that he doesn't know what they actually mean, and they're meaningless. But so he hasn't got a clue what he's doing. Right, admittedly, right from the word go, the only thing he's doing is putting an egg in a flipping jar in a glass and filling it with salt. That's it. So he's got and he bangs on about the scientific method. I mean, where's your scientific method with any of this? Where's your control? Where's your independent variable? Where's your dependent variable? He doesn't know the answers to any of those things in that one experiment. It was just a demonstration.
He just did a party trick and doesn't understand why it happened.
Yeah.
Well, even with that, the whole scientific method process, and I'll just use that egg experiment. Now, as far as I'm aware, when you're conducting any type of experiment like that, you need to remove as many variables as possible. So you would start out with distilled water.
Yep.
You would make sure the water was at the same temperature.
Absolutely.
You would make sure that if you're using 2 eggs in 2 separate glasses, that the 2 eggs weighed the same.
Precisely.
You would go through all of these processes to eliminate every single variable that you can. You would measure the weight of the amount of salt that you placed into the water in solution.
Yes.
Yeah, but you didn't.
Yeah.
You know,
And you'd buy a hygrometer, not a dissolved salts
and that's
meter.
right. You would use a hydrometer.
A conductivity meter would be pointless in this case.
Well, it can give you an indication, but it doesn't actually give you a measurement of the relative density, relative gravity of the water or anything like that.
It doesn't tell you anything about density.
No.
So you want. That's right. You need a hydrometer. Yes.
And it's like I've said before. Geez, I could stick my 2 probes from my multimeter in the water, and it would do exactly the same thing as what he was doing.
Yeah, of course. We just check the internal chart.
Yeah. Yep, that's right. Yeah, exactly. Yeah. So just the absolute. It was the whole thing's just nonsense. I had a look at that and watched a couple of minutes of it. It's just nonsense. And this last video that you had on, he was actually demonstrating Dalton's law of partial pressures. So where you've got two volumes, and so the bromine gas, I can tell it's bromine because of its color of it. So the bromine gas goes from one ball to the other ball. So it's going to, if this one is a vacuum, then this is going to try and fill that one. And I think what he's trying to do is tell us that, well, if space is a vacuum, then the stuff on the have to leak out into space or something like that. But there's absolutely no equivalence between those two experiments. You know what the atmosphere and space, and those two, and a vacuum in a ball and another one next to it. There's absolutely no equivalence there. The other thing is this idea. That me or yeah. This other thing is this negative torr business. How did they get that? How do you get negative torr? Zero is about as far as you can go, and then everything else on top of that.
They got that from, it was probably might have been JM Truth, because JM Truth a while back was absolutely insistent that 10 to the negative 17 was a negative number.
Oh.
I think that's where a lot of them actually got it from. And he was really insistent for quite a long time. And he claims to be a scientist.
What?
And no, he's not a scientist, because he's got this qualification from this online university, which isn't a degree of any description of any science. And he was literally claiming that 10 to the negative 17 was a negative number. I think that's where they got that from. They think that there's negative torr, that somehow it's like a negative vacuum.
It was negative 170, he said.
Yes. So hang on a second. So he claims to be a scientist, but knows nothing about scientific notation.
Nothing whatsoever.
Yeah. All right. I have an egg experiment here from a preschooler's education book.
Yeah.
Okay. Listen to the start. What your child is learning. Investigating what happens when salt is added to water helps your child explore scientific concepts and make observations. This is called cause and effect.
Yeah.
Yeah. But this is for a 4-year-old.
Yeah.
Riley couldn't even get a 4-year-old experiment.
Unbelievable. Yeah.
And what was funny,
I've had arguments about this negative torr stuff with people online that keep denying, about space and ISS and all the rest of it as well. Talking about, it's a negative pressure. No, it's not. And they say, why? Oh, because it's 10 to the negative 17 torr. That's not a negative number. Oh, yes, it is. Yes, it is. No.
Yeah. Well, the other thing is that they think there's a massive difference between 14 pounds per square inch and practically none. That's actually a very, very small difference between those two pressures. So I don't know why they think that. They imagine. Do they think that this space is like a vacuum cleaner or something? Do they?
Yeah. That's pretty much what they have. They think that it just sucks everything. Yeah.
Yep, I think it just sucks. I think also maybe it's because they're not used to working with high pressure. I mean, I work with high pressure air at 3,000 psi, and yeah.
I mean,
when you're doing that, you do realise how much energy there is. 14 psi is not very much.
It's well, when you think about it, if you had a tire and it only had 14 pounds per square inch in it, it's flat.
Yeah, because you need 30, 40, 50 psi depending on the vehicle.
Yeah, that's right. Because you're starting off at atmospheric pressure, so it's actually flat at 14.7 psi. So there's so little difference. Why should they think that it's, why would the molecules? I mean, occasionally you get enough energy for a hydrogen atom or molecule to make it out, past the 100 kilometers, but otherwise, why would it? There's.
I had this talk with someone. How do the hydrogen atoms get out of the atmosphere without escape velocity? Do you know how much they weigh? Do you know how much they weigh?
Yeah.
They float. And up they go.
They're far enough to they ride out there where, I mean, they've got if they've got momentum, if nothing stops them, they're going to just keep going.
Yeah. How does a hydrogen molecule create enough friction to stop it going out?
Exactly. What there's no friction for it to stop it. Maybe it can bounce into something else. I don't know. That doesn't make any kind of sense at all.
But basically, the difference between down here and up there is 6 kilos.
It's nothing. It's absolutely nothing. This is one of the things I tell my students when I'm trying to get them to understand Avogadro's number, and 6.02 by 10 to the 23. I said, go to your average beach. I mean, the guys in Melbourne know about, let's say St Kilda Beach. Go to St Kilda Beach and look at all the sand that you can see around you. All the sand. There is not that many particles of sand on that beach compared to 6.02 by 10 to the 23. There are not that many particles of sand on the beach. That's how small an atom is. Now, if you think about hydrogen, you only need 1 gram of hydrogen to make that many atoms. This is how small an atom is. And every single one of it contributes to the mass of hydrogen. So how could you for a second think that these things don't have mass? That just does not make sense, the slightest bit of sense at all.
No.
And if they have made it up that high, surely they will be going pretty damn quick anyway, won't they?
Absolutely. And you think about something that's small, how much energy would it need to move?
Yeah, it's funny. They get propelled by the buoyant force.
Almost anything would get this, any kind of energy would get this thing to move. Just about any kind of energy would get something that's so small to move. So
that's what. Sorry. I was going to say that's what they don't get about the thermosphere thing. It's so hot up there. Yeah, but there's very few atoms, and they're just moving very quickly.
Yeah, that's right. And we get this thing with satellites. Just this Wednesday, by the way, they tell us satellites are fake. Just this Wednesday, we launched 30 satellites. One of them was the Cartosat a polar satellite that checks out the Earth. And this is again, we say, how do you know the Earth spins? Well, I'll tell you what. This Carto satellite, which we've just put up just Wednesday, this past Wednesday, this Carto satellite goes around the North Pole, South Pole, and just keeps doing that in about 5 degrees off center. And the Earth spins beneath it. So if you think about it, as the Earth is spinning beneath it and the satellite's going the other way, north to south, it covers the entire Earth in 12 hours. It takes a picture of the entire Earth. Every square millimeter of the Earth is taken a picture of every 12 hours. That's how much it does. Huge amounts of data is collected from that. So therefore, if you walk outside there, trust me, they'll know. Okay, so there's nothing you can hide from anybody because these satellites out there can see. If they can actually, we've got them now. This Cartosat that's going up there, sure, I don't know how much I can tell you, but yeah, 30 centimeters. It can, 30 centimeters. It can find. It can resolute 30 centimeters. It's just amazing.
That is absolutely amazing.
That's about the size of the top profile of a human head.
Absolutely. You cannot walk outside without being noticed.
Yeah. But it's going to be all the paranoid freaks that go, oh, they're watching me. They.
Well, yes, they are.
They are.
But if you're not doing anything wrong, why are you paranoid?
Yeah, right. No, that satellite's going around your head, and actually, they say, well, but my privacy. Well, I'll tell you what, they actually don't care what you're doing, but if a storm was coming to get you, you'd want them to know.
Yeah, absolutely. Well, it's like the Orion planes that they used to have flying overhead in South Australia.
Yeah.
Did they realize what was hanging out the tail?
Yeah.
I mean, the lack of understanding of how, I understand we're under surveillance, but the only people that have something to fear are the people that are doing something wrong.
Absolutely. There's people up there have got no time to. They've got no time. There's no time at all to do it. What happens is they target something. They get some intelligence about something and they target something. Then they start looking for specific things. But they do everything they can to not look at shit that doesn't matter to them. Because time is everything. And sometimes
you don't.
You want to know, like yesterday. Especially if there's a truck.
If there's a truck with a thing in it that's going to make explodies,
yes,
you want to know where it is and where it's going.
What do I know where it is now? You don't care about the other junk around it. We're after this thing.
Yeah. But the intelligence is actually one of the most important things. I mean, the RAF unit where I was stationed back in the early 90s was targeted by the IRA.
Yep.
And it was only because a farmer had noticed some people mucking around in a disused building that shouldn't have had anybody mucking around in it. And he actually thought to mention it to somebody at the camp.
Yeah.
That they detected it and put it under surveillance, and things got rather interesting for a while, security-wise.
Yeah, yeah. So and every country, over here in India, the United States, they all have their own version of it because they don't necessarily want to share the secrets with each other. So countries that share secrets are like Aussies and Britons and America. I think about 4 or 5 of them, New Zealand, but they don't share information with India or China or North Korea or anything like that. But they have their own satellites doing this stuff.
Yeah, there's these little things called the Secrets Act.
Yeah. Sometimes that worries me about what I can say and can't say, but yeah. I can only tell you stuff that's published.
Yeah, but like, and I'll say this again, unless you are doing something that's basically terrorist related, most of these surveillance satellites aren't gonna frickin' look at you.
No.
They have no need to. That's what local police is for.
They'll never look at the picture until they need to, until they're looking for a specific thing. Yeah, absolutely.
Yeah, they think there's drones and shit all going overhead looking at them, and that it's they control it all. Well, actually, most surveillance is run by the private bloody sector.
Yes, it is, because it's a lot of stuff done by the contracting.
Yeah.
Yep, absolutely. Yeah.
Well, it's like Pine Gap. Half the people that work there are actually contractors.
Yes. Well, we've got no means of putting putting stuff in space. So we have to get other people to do it. We get the Indians to do it. We get the ESA to do it. Depends on where it is. So the Indians are very, very handy because, you know, it doesn't...
They're not far away.
You get a satellite in for about a quarter of the price, maybe half the price.
But we're going to have one soon.
Yeah, I know, in South Australia, yeah.
Yeah, I'm very happy about that. They start building it next year.
Yeah, no, it'll be interesting. I wouldn't mind doing some stuff for them, but like I said, I'm 65 now, so I'm sort of getting to the stage.
And you think someone like NASA gets rid of 65-year-old scientists?
Well, I don't know. It's only in Australia is about the only country in the world where they say you must be getting done because you're older, right? So get rid of the old, But other places like over here, the older you are, the more they respect you.
Yeah, your age is your credential.
Well, you've lived long enough to learn those bloody things. So if that alone should tell you, that doesn't work like that. No.
Yeah, this age thing is something that is really getting my goat about some of these flat earthers, because they're around my age.
Yes.
In the 40s, right?
Yep.
And to believe this fantasy at that age is just it's like being 45 and still thinking Santa is who drops presents off to you.
True. Yeah. We actually did a group from our psychology faculty actually did a bit of research on this, and you hit the nail right on the head. The biggest group of flat earthers are between 40 and 55. Mostly Westerners and mostly men. So there's an interesting...
right on the edge of the danger zone then.
There's an interesting statistic. Yeah, so I don't know. So the psychology people say this, and I don't know, you may disagree with it, but what they're saying is that they've a group of people who've sort of are watching technology just fly past, are forced to use this technology and don't have a clue how it works, and are feeling, kind of left behind and threatened with it. So they're using stuff they don't know whether to trust or not, and they have to use it. So they feel like they're being left behind. So
yeah.
Yeah.
Yes, because and they're only able to communicate the way they do by using the technology built by the science and engineering that they are claiming doesn't exist.
Yeah. But they resent that. They resent the fact that they have to do that. It was they like the idea. They wish, like you've got that beautiful Holden, that they like the idea. You could pop the bonnet, fix the carby, you could look around it, put a light meter on it and fix your timing right. You could do all of those things. Now you can't do anything. You just open up and there's a great big bloody plastic, I've got mine. I've got this great big Mercedes thing right in the middle of it. I open it up and I said, I don't have a bloody clue anymore. I don't even know where the damn battery is.
It's in the boot, mate.
It's just, but I mean, so I'm not intimidated by that. I know that it's got to go that way, but some people will be intimidated by that. And yet the young people, the really young ones, the ones who, who are, 30 or less, for instance, they were born with the stuff in their hands. They had the technology when they were born, so they're not afraid of it at all. Nothing can surprise them.
Yeah, I think with the young people, it's interesting because they're not scared of the technology. They'll use the technology, even if they don't necessarily understand the technology.
Yeah, exactly. And they trust the people who make the technology. That's a key point.
Yes, because it's always been there and always worked.
Yeah,
I have a statistic for you.
Yeah, go ahead.
Yesterday was the PlayStation's 25th birthday.
Wow. That old. Wow, it just seems like day before yesterday when that was started. But there you go.
Yeah.
Just goes to show. Yeah. No,
but that's what I mean. Like I was like 19, 20 years old when that came out.
Wow.
Okay, so I had 18 years before a particular piece of technology was released.
Wow. Fair income. Oh, well, when I first graduated, actually I was in second year. I was in second year before I actually got it, before the calculator was invented. So that's when we finally got a calculator, and before that was all slide rules. So I don't know.
I remember first being introduced to computers in primary school, and they were Honeywell computers with the orange screens.
Yeah, that's right. Well, I did my first computer course at Melbourne University, and there were no screens. They had not invented screens. So you typed into the machine, or you punched out the holes in these cards, and you put it in there, and that the machine ran, clunked away, and spat back some words at you on a huge typewriter. That was really the in thing then. I remember I had to take one of these home one day, and I had to about 5 people take it back. So that was then. I mean, now you got a calculator that's more powerful than the entire computer that we had.
Actually, here's a good question from the chat. How many people know how a refrigerator works?
Okay.
But that's the same thing as saying, do people know how an air conditioner actually works? Do they think it actually blows cold air, or is it removing heat from the atmosphere?
Yeah. I don't think that's another good point, because that's another thing that flatties don't understand. Because I've heard them say this. I think even Riley said this. Well, why don't you believe in satellites? Well, because the thermosphere, everything, it's 2,000 degrees up there. I said, hang on a second, it's not. It's only 2,000 degrees for something that gets that hot. We still have to have radiation, but it's not like the whole place is 2,000 degrees. It's a particular thing that happens to be in the way of the energy might get to 2,000 degrees, but not the whole thing. And then it's only going to be hot on the side that's facing the sun, where that's actually getting the radiation. The other side is still minus 270 minus 270 degrees, so nearly 0 Kelvin on the other side of it. Now, when you put those two together, the satellite goes around there, in the thermosphere, probably about, anywhere from minus 170 to about 250.
Yeah, actually, there's 2 examples of why their thing is wrong. Okay, the SR-71 maximum ceiling was let known 81,000 feet.
Yeah.
Right. And according to the FLIRS, it's hot as hell up there.
Yeah.
But the plane didn't melt.
No.
Actually, 81,000 feet is not hot as hell.
No.
It's pretty damn cold. It's just if you're if you're blasting along at 2,000 miles an hour, you're rubbing past the molecules that are there pretty damn quick, and they kind of rub against you and make a bit of friction and start warming you up.
Yeah, but this is where the disconnect comes from. Okay, Felix Baumgartner went to 128,000 feet.
Yeah, why didn't he burn up?
Yeah, why didn't he get cooked in his suit?
Yeah, exactly.
Inside that metal box he was in.
Yeah,
because he wasn't going fast enough.
Yeah, that's what they forget. It's velocity that creates the heat.
Yep. Yeah, they seem to forget that actually happened. That they admit it happened, but no one stops to think about why he didn't burn up.
Also, the fact he has been
15,000 kilometers per hour. That's why he didn't burn up.
He's also the fastest human ever
Yes.
Non-powered flight. He broke the sound barrier as he fell to the earth.
Yeah, that would have been awesome.
That's why he had to wear a pressurized suit, so he didn't
yeah.
get like vaporized.
Yeah, that would have been awesome.
Yeah, I'd have done that. I would have loved to have done that.
Well, I reckon I can tell you now, just in probably 2 or 3, I think probably 2 or 3 years' time, you'll need about $250,000 you can go for a ride in an actually in outer space.
Well, actually, according to Virgin Galactic, they already have 64 people lined up for the first flights.
Oh, there you go.
Yeah. So their launch center in New Mexico is already being prepared for the launch mechanisms.
Yeah.
Okay. So it's still going to be the plane takeoff and then launch from the back of the plane.
Yeah. So what are the flights going to say then?
Is this going to be suborbital or full orbits? I'm sorry, I've not been keeping up with it.
Yeah.
As far as I know, if you go past the Kármán line, you're classified as orbital.
Yep.
Well, as you're classified as an astronaut if you go past the Kármán line.
Yes, correct. Over just about 100 kilometers.
Yeah. Yeah. Well, I believe because it's actually a legal technique. It is actually set in international law at 100 kilometers, because it's the difference between aviation treaties and space treaties.
Correct. Yeah.
In international law.
And it's also the difference between 14.7
and practically none.
10 to the negative 17.
Well, not quite 10 to the negative 17.
But it's pretty damn close once you get past the Kármán line. It's that far apart.
I know originally that Kármán set the altitude because it's the altitude above which a wing, no matter how fast you fly, no matter how quick you go, it's the altitude that wings stop working.
Yeah,
they don't get lifted.
Possible, yeah. Actually, the wings would stop working long before that. Long before that, because by the time you get to be, it's kind of an exponential drop in the amount of moles per cubic meter. So I would suggest you probably couldn't fly a plane much above 60 or 70 unless you're going really fast. So Concorde would have probably made about 60,000, but that would have been really stretching the end of it. 80, no, not a jet airliner. We'd never get it.
And of course, and you still got the problem of being able to run your jet engines at that altitude, haven't you?
That's the problem is that unless you're carrying your own oxidizer, you don't have enough oxygen to sustain the combustion.
No.
So I mean, this is the whole thing about a rocket. So we actually have a controlled explosion with either liquid or solid oxidizer and liquid or solid fuel, and this is a huge explosion that happens at the ground. And this idea that we push off anything, well, we go through a lot of trouble to put. If you go up to one of these launch pads, it's actually like a box. So the rocket's sitting above a box, and there's this great big hole in it below where the flames come out. And the whole idea is to try and get rid of this exhaust. We're not trying to. When this exhaust isn't pushing anything up, we don't want it. We want to get rid of it. So this hole in this box is so that the exhaust will go down, and then as soon as there's actually water jets inside it, watering the hole,
all down.
trying to keep it cool. That's why you get all this steam as well. You notice when a rocket's going up, it's not just the fuel, but you can actually see the steam. The steam's coming up from the box below it. This rid of the heat.
I was lucky enough 20 odd years ago to visit to go to the visitor center at Kennedy Space Center.
Yeah.
And we did the tour which included the pad they launched Apollo 11 from.
Yeah. Oh, beautiful.
Although of course, at that point it had been modified because they were launching shuttles from there as well. Or at that point,
Pad
it
39.
was amazing. Pad 39A, that's it.
Yeah.
It was amazing just to be able to walk around on it. To be honest.
Yeah.
Yeah,
Well,
yeah. Just remember all the residual chemtrails that you're walking through. Jeez, come on.
But yeah, I mean, just especially as Apollo 11 is the oldest memory that I've got. Is being got up by my parents as a. I was a month shy of my 5th birthday, and I can that I can remember. Being sat down and watch this because. And seeing it all happen.
No, it was pretty amazing. I was about 12 or 13 years old then. It was a great experience. Yeah. So when you saw the launch pad at for Apollo, you would have been standing on, knowing that you're standing on a huge, the top of a huge cavern. So beneath your feet would be this cavern that would take the brunt of all of that, the rocket. Exhaust that's coming out. So it's not like that has to push. Okay, it's
and you can even see because when you look down into it, you've got you've got essentially got these huge vent openings at the side for it all to come out of.
Yeah, exactly. That's precisely it. So not only is the openings on the sides, but you also have the sprinkler systems and all of that to huge high pressure jets of water to actually cool it down. It's quite a big feat just to cool it down. And I tell flat earthers sometimes, they say, well, how can the rocket put, it needs the atmosphere to push off. Well, it doesn't. Put a bazooka on your shoulder. A bazooka is just a pipe. It's just a pipe and it's got the projectile in it and a way to trigger the
propellant.
Yeah. That's all it is.
Yep.
Well, there's a rocket right there. That's exactly how it works. It doesn't push against anything, because if it did, and you had this on your shoulder, you'd be flying backwards for miles.
Yeah, the force of the accelerant pushes the projectile out.
Yeah, exactly.
And just don't stand very close behind one. It's not a good place to be.
You don't stand behind one.
Yeah, you get no face.
Every action is an opposite and equal reaction, correct?
Yeah. Well, it's not just that casual. It's the fact that a 20-meter flame comes out the back of the dang thing.
Yes.
Yeah.
I have noticed this, Alan. Yeah.
Yeah.
Actually, I remember how Neil deGrasse Tyson debunked what goes up must come down. All right. Voyager.
Yes.
Pioneer. Mariner. Cassini. Huygens. New Horizons. They're not coming back down.
Skylab.
Actually,
that did come back down.
Anything in the graveyard orbit. So when the satellite's finished and we've got to replace it, if it's in geostationary orbit, then what we have to do is we turn the thrusters on and get the thing to go 40,000. So from 36,000 to 40,000 kilometers. And at 40,000, there's plenty of stuff up there of junk, and these things will just go on indefinitely. It's called the junkyard. It's called the graveyard or orbit.
Yeah, orbit junkyard or graveyard. Yeah. Uh-huh.
Actually, my first memory of anything space related was images of Voyager going past Jupiter.
Yes. Yeah.
I think that was
I've actually
81 or 82.
I had an oversized book I had when I was a kid. I treasured for many, many years. Sadly, it got destroyed in a fire. And it was one of those hardback books. I mean, to me, it looked absolutely freaking huge. And it was all the images of Voyager 1 and Voyager 2 going past Jupiter and Saturn and all these different images. I was awe-inspired by it.
Oh, cool, casual.
That was all CGI.
Yeah. Yeah, no. Sadly, the book got destroyed in a fire. So yeah, I treasured that book because it all had pictures in it. Because when I was a kid, that's what I liked.
Yeah, we only looked at pictures, do we?
Well, I mean, you're an example of having a look at that and being excited by it and say this is fantastic and just being really interested. What happened with these Flurfer people? Did they just lose any sense of wonderment?
Well, I think to be honest with you, I've had discussions with people about how these conspiracy theories came about, and I think if you look back, particularly from the sort of 1960s, media was really becoming something of its own sort of character. It was becoming a big thing. News could travel around the world much quicker, in the 60s and 70s onwards. And then you had things like, the big scams, I say scams, but big controversies, things like Watergate was a prime example. I often use that as a great example because that was one of the biggest, what's the word I'm looking for? Sorry, I'm tired and not well.
Cover-ups.
Controversy, yeah, whatever. Of the time as well, and I think over the years, and also with the way media has developed and the internet and social media, people have developed over time of a mistrust of authority, and particularly in the government. So they kind of see government or any kind of agency or anything like that represents what the government might represent, or even a loose connection. And people have become more and more mistrusted. So then you got the advent then of the internet, where it allowed people to actually pretty much say whatever they want. You can create a character online, and you can be whoever you want to be. And once if you're able to do that, you can say whatever you want to say, and people will actually believe it. I think that's part and parcel because, back in the 50s and 60s, it didn't have the internet. So it was much harder for people with conspiracy theories to actually spread it. And you go back to 75, 76, when the moon landing hoax first kind of kicked off, and I forget the guy's name. I always forget it, that started it. Somebody could probably remind me in the chat, I'm sure. Where the only thing he had was basically he just started giving out leaflets to people, and that gradually over time built up. So, but I mean, conspiracies are not necessarily a new thing, but I think that's basically what's happened is that people are using the internet and believing everything they read on the internet, and particularly in social media. And you mix that in with kind of like a mistrust of authority and government. Yeah. And this is where it all comes from. And that's why they're saying to people that, flat earth is just a big conspiracy lie. When, if you look into it and actually sort of look into it deeper, it's not only is it ridiculous because it's not true, it's ridiculous because it's such a huge conspiracy. It would be just impossible to manage because of the sheer number of people involved in order to peddle a hoax like that. Yeah. But that's I think personally that's my whole theory behind it, and I think it's just over time, over the last 50, 60 years, that's how it's all kind of developed. I think that's personally how I feel about the modern flat Earth.
So how do they explain that? I mean, here where I am here in India, we've got about 3,000 people working in our section, so working on satellites. So the people who build it, the people who build the rockets, all the people who carry the rockets to the side. Then you've got an assembly. You've got all of that. There's about 3,000 people involved in all that. How do you get 3,000 people to keep a secret?
Well, this is the thing. The argument I've got back from that is that it's on based on a need-to-know basis. The top people know everything, and then you've got layers of people that are supposed to know more and more, less and less and less as you go down the tiers.
Yeah.
So the guys say working on, say if they're working on a spacecraft, they're working on the propulsion.
Yeah.
Wouldn't necessarily know anything about another part of it, and when they launch a rocket, all the people that have actually built all these spacecraft, built the rockets, as far as they're aware, it's a real thing and it's going up in space. But the people behind the scenes are the ones that really know what's going on. But even the people behind the scenes at the top levels, there would still need to be an incredible amount of people.
Oh,
You know,
wow.
that's what I'm getting back from people. That's what they're saying. Because I argue about the moon hoaxes and landings and stuff like that with people all the time on social media and Facebook and all kinds of different things, and that's what I get back from people.
Well, the thing is that I get what they're saying, but just say someone like me, do they actually think that they could actually fool me? I'd have to be really stupid, wouldn't I?
Well,
I mean,
yeah, exactly.
Yeah.
How are you going to fool me? Why wouldn't I know that that this is just bullshit? You know.
But I mean, you know, putting sort of like putting the moon hoaxes aside and all the rest of it, right? Okay, let's just take flat Earth, right? You know, that would be even more difficult to manage because you would have to have so many people that actually knew that it was a big hoax to actually hide it. It would be, faking the moon landings is one thing, and that was incredible. That must have involved hundreds of thousands of people if there was a real hoax. But then, if you think about a flat Earth, I mean, that's a globe. That would have to be a global hoax, but on a huge scale. You know, and that that's why it's just so impossible to actually believe, or for anybody, or they shouldn't actually believe that it is actually a hoax.
All right, Mr. Spaceman. 2 things that have happened in the last 30 years that means that they're not keeping a bloody secret. 1, a president couldn't keep a blowjob a secret. 2, another president couldn't keep a phone call a secret.
No, exactly. And that just involved a few people, let alone hundreds of thousands or even millions of people around the world.
Yeah, exactly. Now, I want to change tact for a second, okay? Because I just noticed in my bookshelf, if I've got the photo, hang on, I'm going to have to move it from my gallery. But I found a book called Prehistoric Australia. It was written in 1979. It has a picture in here of the pubic bone of a bipedal dinosaur in the wrong configuration.
Okay.
So instead of having the front pelvic bone facing back behind the legs like in a bird, it's pointed forward like a coccyx, being pushed forward. But that was 1979. It was a few years later that someone decided to turn it around, and it changed the whole way the dinosaurs sat.
Well, there you go. Yeah, well, that's science for you.
Yeah, but science isn't allowed to change anything. It has to be right. It has to be that fact.
Well,
no, that's not science.
My opening line every single year to the students that in there is, there is no truth in science. We don't look for truth. If you want truth, go to your church. You won't find it here, because we don't believe in truth, because we're desperately looking for the thing that the one before that. So there won't be any truth, because we'll change. Truth is finite. Truth means there's no more after that. You don't have to look anymore. You don't have to study anymore. You've got it. That's the truth. Well, that doesn't work, because no matter what it is that we've discovered, we still try to get better at it. So there's no truth. We don't prove things, and we don't have truth. We just say, here's the hypothesis, and here's the evidence supporting the hypothesis. And this is how you can use it to make predictions. If it makes predictions, it's good for a model, and you can keep using it and hope, and maybe someone will come around one day and change it and make it better. And there goes your truth.
Yeah, same thing happens with engineering techniques. They get better and better and better. But no one says you have to stick to the 1960s architecture.
Unless you're a flat earther, by the sound of things.
Yeah, but why stick to that when there's better designs, better materials, better ways of going about building it, better techniques to put it together? I mean, it's a myriad of things. The fact that the mobile phone that you use now has a more powerful processor in it than was what was on Apollo.
Yes, yeah, absolutely. Yep.
I think your average phone these days probably has more processing power than NASA had in '69 for the entire Apollo mission.
Absolutely. Well, you know, when I first started my degree, we bought a computer for Caulfield. It's now Monash University. It was Caulfield Tech in those days. Caulfield Institute of Technology bought an ENIAC computer from Britain, and that had all of 640K. It was like the main thing. 640Ks. That was like the biggest, you know, one of the in the world. In terms
if you think about it though, Professor Phil, if you think about the Apollo spacecraft, okay, you got the command module and you had the lunar module, right? I mean, it was quite. Once you break it down, I mean, everybody says, "Oh, it's a complicated spacecraft," but once you think about it, it actually isn't really. You know, what does a spacecraft got to do? It's got to go got to get through the vacuum of space from A to B. Yeah. Okay, it's got to be able to navigate. Okay, yeah. which as we know, the Apollo astronauts had to make corrections because it wasn't perfect. But other than the navigation system, all you've got is a set of thrusters and some main engines. It's pretty much all you've got. So really, once you break it down into its constituent parts, it's not that a complicated thing. So the computers didn't really need to be super duper high tech and all the rest of it. Would you agree with that? Do you think?
Totally. Look, I'll give you a secret, okay? So even it's a secret on the internet, the whole world can read. All right. So people used to say, well, you know, this isn't rocket science, you know, because they assume that you must be really super smart, you know, worked on a rocket, and they say this isn't rocket science. And sometimes students tell me this, and I said, listen here, just keep this to yourself, right? Rockets are not that bloody hard to do. Okay? No. We're not geniuses because we put rockets in space. Okay, this is just a controlled explosion. That's all it is.
Yeah, you can make one with a plastic bottle and some bicarb soda.
Yeah, look, I say to you, think about this when something's going to orbit. Let's say you were kicking a football, all right? And you kick the football. Well, it's going to go in a parabolic motion and then land on the ground. If you kick it harder, it'll just go a bit further. Let's say you were Superman and you could kick that ball so hard that it didn't land on the ground anymore. That's called an orbit.
Then it would mechanics 101.
And hit you in the head. That's an orbit. Okay, you kicked it hard enough for it to not land on the ground anymore. So that's what you call it.
Oh,
yeah. And to get the moon, they just pushed a little bit harder so they can increase their orbit. So it actually coincides with the moon. That's all it was, really.
That's all it is. You just got to get there. You just got to go. You've got to put enough bloody fuel and oxidize on it so that it'll go far enough. It's like kicking the ball as hard as you can, even harder. The most. And so obviously this rocket. Still the biggest rockets that's ever been made, even today.
A question I have. Okay, a lot of the globe denying crew turn around and say, you have to use the scientific method to make your observation.
Yeah.
Well, no, you don't.
No, you don't. Oh God. I actually had somebody as well said to me on a chat once before. He said, prove we went to the moon by using the scientific method. What? Come again?
Yeah.
But that's easy. My hypothesis is we went to the moon. How do I prove it? There is video footage of people going to the moon.
That'll do it.
Do it.
That's only a two-step science.
What about all the satellite pictures of What about all the satellite pictures of the landing sites?
Oh, yeah. Actually, it's a bit of news. I don't know if you guys know this, but we actually know where the Vikram lander splattered all over the moon.
Yes.
It's 4 kilometers wide. You know, when it hit, so obviously hit and bounced and broke up in a 4 kilometer radius, unbelievably fast. So it just goes to show when something's really moving on the moon, there's practically nothing to stop it from going. So, you know, because normally an airplane, even a huge jet, you know, hitting the ground, you might have a kilometer of debris, but this is 4 kilometers of debris from a very small craft.
Yeah, well,
this goes to show that when it's moving, nothing stops it.
Yeah, and no form drag on the debris as it's following its parabolic paths after impact.
No, just yep, that's it. There's a bit there and there's a bit there. So the way they know this is what happens. They see all the because the Chandrayaan space probe is still going around the moon. So there was two parts to it. There's one, the orbiter, and then you've got the actual lander. All right, so the two different components. Well, the orbiter is still going around the moon. In fact, next November, we're going to send another a special probe that's just going to catch up with the orbiter and actually attach to the orbiter, so they can have another go at it. Now, the I've lost my train of thought. Yeah, so no, doesn't matter. I've lost it. Go ahead.
That's all right. I do that all the time. I go into like a flow of stuff, what I'm talking about, and then halfway through completely forget the point I was talking about.
Well, okay, so we've now seen the 4 kilometers worth of stuff on the moon. It's spread over 4 kilometers. But the interesting thing from a physics point of view is, how does it get to be 4 kilometers away? That sounds ridiculous, you know, for a small craft. You know, that's just the size of a box. How does it get to spread to 4 kilometers? And the reason is because when the energy that hits the ground, and then each and every component that is taking off, and there's nothing to stop it. So this is Newton's first law of motion. It's going to keep going until there's something to stop it. So yes, there's a bit of friction there, but and there's 1/6 of the gravity. So eventually it will stop because it's not going fast enough to get out of gravity. But it'll stop a long way off. So it just goes to show there's some more physics that demonstrates how Newton's laws work.
So that was.
Yeah, go on.
Because that's part of the problem that some of the Apollo deniers have, because when things like the dust being thrown up by the lunar rover and the dust being thrown up by people, it looks wrong. Well, of course it looks wrong because it's in 1/6 gravity and there's no atmosphere slowing the stuff down.
Yep.
And exactly. Making it below, and especially with lightweight dust, because you get the dust up in the atmosphere, and then very often the particles are light enough that atmospheric atoms can push them around and hold them up with buoyancy.
Yeah, they'll hang around. They'll be buoyant. You're quite right. They'll be buoyant, and you'll be able to see them in the light smoke and stuff like that. But
yeah,
if the smoke particles could move so fast with nothing to stop them, you wouldn't see the smoke.
Yeah.
You only see it because it hangs around. And it hangs around because it's buoyant. You know, it hasn't got enough energy to keep going.
Yeah. Unless you think about it, you don't think, what are these things going to do on the surface of the moon when you move them around? And when the only thing you've got to compare it against is what happens here on Earth, it will look wrong because you're so used to the fact that it's doing it with a gaseous atmosphere 14 psi.
Yeah. Yeah, exactly. Yeah, exactly. Just wondering if there's anything here to people asking questions in the chat. Okay.
Oh,
Somebody-
Montreal was asking a few questions.
Yeah.
He thinks radioactive decay is entropy.
Oh, no, it isn't, buddy. Okay, that's something quite different. This is actually the element losing some of its mass. Okay, so a typical example would be, you enriched uranium, and that's how we get nuclear energies, because the element is losing some of its mass, and in losing its mass, it's got energy, and we use this energy. Nuclear, that's what nuclear energy is.
But we accelerate that decay rate to create the energy.
Yes, well, we can hit that. We can bombard so
Yeah,
in a
we knock the
nuclear,
electrons off it. Yeah.
yeah, or actually hit it with a neutron and knock some neutrons out of it, and then so 2 neutrons come out of it, and these 2 neutrons bombard another 2 neutrons, makes 2, 4, 16, and so on. So and all of this happens in an absolute a nanosecond, 10 to the minus 9 of a second. All of this happens. So imagine all the huge amount of energy that's just been released all at once. That's an atomic bomb.
Yeah, it's like the amount of cesium required to run a atomic clock is so minuscule.
Yep. Yeah, exactly.
That it will last for what is it, 300,000 years?
Yeah.
Well, they're only using the cesium as a time constant in reality. So
yeah, because of the atom release.
Yeah, they're not actually running the clock itself off the cesium.
Because cesium is one of those one of the element. It's so predictable. Its release of the radiation of the particles are so predictable. You can absolutely time them, and they're always the same. So therefore, you can use it as a clock.
Yeah, it wasn't about running the clock. It was about the element itself lasting for so long before it actually expires.
Oh, well, I mean, it's, from our point of view as humans, it's practically indefinite. Okay. And this is obviously one of the problems with radiation anyway. We're talking about stuff that's going to outlast humans.
Yeah, well, I've actually watched most of the periodic series.
Yeah.
And yeah, watching them go to the storage place where they had plutonium, uranium 235, 238, some of that I can't remember what it is.
Thorium.
That's the one. Yeah. But seeing how they have to be in a protective case and you have to put the gloves on, but the glass on the front has stained yellow from radioactive decay.
Yeah. Yes. Yeah. No, yes, and over time, that's how the Curies basically discovered this stuff, because it exposed a photographic plate that Mrs. Curie put the lump of radium on, and realized that that something was exposing the photographic plate.
Apparently, her desk and a letter of hers are still radioactive.
Yeah, exactly right. Yeah, that's right.
Yeah, it's a funny thing. In the 60s, I think it was, might have been the early 70s, Canon were using glass with trace amounts of thorium. I think it was in the glass for their lenses, for their high-end lenses, and they have gone yellow because of the radioactive decay.
Yeah,
And they're actually now highly sought after because people think there's something wonderful and interesting. It was just one of those things that it turned out that there was, some thorium in the mix that had this effect. But you really wouldn't think you'd want something radioactive in your lenses for your camera.
I think when we talk about something radioactive, you've got to talk about about how much of it there is, how long you're exposed to it. That's the main thing. So and
what
you've got enough energy to escape from wherever you have it. Let's say they talk about the Van Allen belt. This is another one of the. So we're talking about alpha particles. So a piece of paper could stop alpha particles. So why wouldn't some aluminium shielding do it?
Yeah, but it's because they think it's like nuclear radiation.
Yeah, and that's the problem.
And it's nothing like it.
So they just say really, really dumb things.
It's the fact that the Van Allen belts are more dangerous to the electronics systems than it is the humans.
Yeah, we're talking about electric and magnetic fields and stuff like that. These things will affect electronics. Of course they will.
Especially now we're down to sub 10 nanometer feature sizes.
Yeah.
Because a feature size that small only requires one photon to hit it, and it could very easily change its state if it's a digital, if it's a digital memory component, and that was one of the advantages that the low tech of Apollo had, in that the transistors and what have you that they were using were really, really big, so the radiation didn't have such a proportionately large effect on them.
Yeah, mind you, it's not without risk. But you've got to be able to, for instance, the path that you take through when you make the initial transfer orbit, you're going to take a path through let's say a polar path to avoid going through most of this radiation. But you still got to be mindful of the fact that there's cosmic radiation, so you've got to do shield from that. But we're not talking about having to have lead or anything like that. That's just ridiculous, because it's not the type of particle that we're worried about.
Unfortunately, they don't. Again, it's not something you tend to learn about, is it?
No,
I only know about it because during my RAF service, my main role was being a technician and keeping the radar turning. Yeah. But my secondary role was nuclear, biological, chemical decontamination. I worked in the decontamination centre.
Oh, wow. Okay.
So we had to learn that stuff.
Yeah.
So that we knew what we were dealing with, so that we didn't
do anything dumb.
Yeah, do anything dumb.
Yep. Yeah. Unfortunately, I know of some people who have done some dumb things, and the cost was very high.
Yeah, it's interesting to see that. I saw one of the nuclear factories in America. Can't remember exactly where it was, but it's where they make plutonium there.
Yeah.
But it takes forever to make it. They actually reuse spent rods.
Yes.
To create other elements. But it's the fact that the water that those rods sit in has this eerie blue color,
which is radioactive too.
Yeah.
That's probably Oak Ridge, Tennessee.
I think it is. But the thing is, you can walk near that water and it won't do anything to you. But the moment you touch it,
That's different. Yes.
Yeah, you're stuffed.
Yeah.
But it's the water that keeps all the radioactivity at bay.
Yeah. Yeah.
Yeah,
It's weird.
drinking it would be about the
Whereas
worst thing you could do.
Yeah.
And you know, there's two types there of this water. There's the heavy water, which is hydrogen that has the neutrons. So
That's deuterium, isn't it?
yes, there's tritium and deuterium. The deuterium's got the 2 neutrons, and the tritium's got 3. So these different amount of hydrogen. So natural hydrogen has got no neutrons. It's just 1 proton. And then you've got 2 neutrons or 3 neutrons, and obviously if you're making the water with, let's say for instance you're using deuterium, then that means that you've got 2 hydrogens. So now that means that you've got 4 neutrons, as well as those 2 protons that's in the hydrogen, and then you add that to your water molecule, which which will have another 8 protons. So it's a much heavier percentage-wise. It's much heavier than normal water. So hence heavy water.
And if you freeze it, the ice cubes actually sink.
Yeah. It's heavier.
I've got a question for you.
Yeah.
Professor, have you seen that? It's from the chat, but I've actually seen the video too myself. Have you seen that video where the scientist eats the uranium and swims in the pool with the depleted? Have you seen that particular video?
No, I haven't. I guess uranium is not that scary if you haven't enriched it. I mean, I've held uranium in my hand, yellow cake uranium in my hand. I've done many times. Someone will give me a bit of that. I'll say, oh yeah, that's yellow cake. And it's no big deal. I mean, we're talking, if it was enriched and then became a pellet, well, I definitely wouldn't be touching it then. But just the ore is, it's neither here nor there. You can.
In its raw form, it's quite safe. You're saying?
Yeah, of course it is.
Right.
Yeah.
If I remember rightly, it has a very long half-life, which means it emits its radiation very slowly.
And
what about the point where you actually
the amount of radiation of the amount of fissionable material is very small in a lump of yellow cake. So you've got to enrich it. So now you've got to put it through a centrifuge. The centrifuge has got to remove most of it, and then keep re-enriching until you get enough fissionable material. That's why it takes so long, and that's why it's so damn expensive. So it's not like you go and dig up a bit of uranium and just turn it into a pellet and Bob's your uncle. A lot of work to be done, and that's why they're worried about people like the Iranians and the North Koreans and not having centrifuges, because you can't do this job without these centrifuges. It takes a long time to get a kilogram of the stuff, and without this equipment, there's no way to do it. It isn't an easy thing to do.
Apparently, he swims in a pool that has got the depleted rods in it.
Okay.
Well.
If they're capped, they won't do anything to it.
That's right. If the rods are not exposed to,
nothing will happen. Yeah.
So what the whole idea is so that they don't have any fissionable material escaping.
Right. Okay.
The place I was talking about, where they put their spent rods, they actually use those rods to create chemical reactions to create other elements.
Yes. Yeah.
That's why it irradiates the water, because of the work that it's doing under the water.
Yeah.
Because it's not a nuclear power plant. It's actually where they turn uranium basically into plutonium.
Yes.
But they also get other elements come off it because of the loss of neutrons or protons or electrons. Will create different elements depending on whether they go up or down. If they go up, they get to plutonium. If they go down, they get to something they actually get to cesium.
Right.
Yeah, that's a long way to go, of course.
Yeah, but that's how far they can go at that plant. Is that far by depleting particular radioactive materials.
I mean, essentially, the difference between one element and another is how many protons there are and how many neutrons there are. So how many protons there are determines one element from another. And for instance, so 238 and 230 and 235 are only different in the number of neutrons that they have. Okay, so they're still uranium, and in order for them to be uranium, they need a certain amount of protons, and if they, plutonium 239, for instance, they just have to have. So every element is different by the number of protons that it has. And the isotope of the element is different by the number of neutrons that it has.
Yeah, because is there 2 or 3 different plutonium?
Well, 239 is the standard fissionable plutonium. I don't know enough about it to tell you about the other isotopes of it. But yeah, so 239 is the fissionable one. And then you've got in uranium 238 and 230 and 235.
Yeah.
Yeah.
238 was used in the 1945 nukes, wasn't it?
Apparently, the stuff was enriched. It wasn't yellow, according to.
Yeah, no. Oh.
Actually.
Oh, what, the stuff that the guy supposed on the
guy, the stuff that the guy ate, yeah.
I'll have a look for it.
Yeah. Have you got the link, Montreal? Can you drop the link?
Yes, so you're going to, you're talking about fissional, so you're going from 235, 238, 239 plutonium. So I don't see any other isotopes that you have. So the fissionable stuff is 239 for sure. And by the way, it's called breeding, just a matter of interest. Okay, so I've got to get ready for another meeting shortly. You guys still online?
Yeah, we're still here.
Yeah, we're still here.
We're listening.
Okay. Yeah, no, I've got to get ready for another meeting shortly, so I'm going to say good night. Good night.
Okay then.
In India, so I'll chat with you another time. It was fun. Thanks very much.
It was really nice having you here.
Thanks for coming in, Phil.
No worries. Loved it, every minute of it. Thanks very much. Okay.
That's good.
All right,
See you later.
I'll catch you later. Okay. Bye-bye.
Bye.
Bye.
Ah. Now what are we going to do? I was going to watch a video, but it wasn't appropriate at the time for what we were talking about. I might end up finishing up soon anyway. We've been going for nearly 3 hours.
I was going to shake a leg and go anyway, so yeah, because I'm starting to feel a bit crap again. So.
Yeah.
Oh, bloody keep your death to yourself, will you?
That's exactly what I'm doing, so you can't catch it.
Oh, yeah, that's right. Haven't you known about the DNA internet
Bloody
transfers that have been happening
picking on
lately?
me again. Oh, Terry, tell him he's picking on me again.
Yeah, don't pick on the sick old man.
Yeah, exactly. Less the old.
Oh, okay,
sick
sorry.
And old. Yeah, sick and old. Just remember that.
Yeah, okay, I'll remember that.
Yeah, bring out your dead. Bring out your dead.
Oh, I was close to that last week. I never felt so bad as I did last week. Oh, God.
Yeah, I know. You wouldn't stop complaining about it either.
Well, Well, I've got to. I'm British. I'm a limey. We complain about those sort of things. We
He's
have to.
still complaining about it, and he's over it, Nilly. What are you talking about?
I know. What can I do? What can I do?
Man,
Listen, have a good one. That was an interesting conversation. I like listening to him. So.
Well, hopefully we can have him on as a regular now and again sort of thing.
Yeah. We'll have to do a session about. We could talk about how they actually got into orbit and how he got to the moon and all that kind of stuff as well, because he's pretty good with that kind of stuff. So.
Yeah.
How they got to the moon would be a good one.
Yeah.
something for Bandy to chew on.
Wow.
Yeah, something Bandy. You might actually learn something, Bandy.
Oh, that's harsh.
Well,
That's harsh.
I took it easy on Professor Phil tonight.
Yeah, okay. You go easy on him.
You took it easy.
Oh, Bandy.
I don't want to go
Bandy, you were in awe.
All right. See you later, guys. Take it easy. Have a good day.
See you later, Casual.
Later, Space Casual. Oh dear. I'm going to go and make a coffee.
Yeah.
So talk amongst yourselves, unless you want to watch Isaac Butterfield for 10 minutes.
Yeah, we can chat.
No, I think we're better off chatting than just running a video.
I can only do so much, Isaac.
Okay. I'll be back in a sec.
Yeah, that was a really nice chat, wasn't it?
Yes.
No, but it's the fact that you don't have to be scared of someone who is smarter than you.
No, not at all.
But Bandy, have you noticed that this is what happens to some of the people in the flat Earth community, though?
Oh.
No, they become defensive because you start to show that you actually have a little bit of knowledge.
Well, knowledge can be a powerful tool, most definitely.
Yeah, but the moment you become afraid of somebody else's knowledge, means that you're not willing to accept it.
Well, yes. No.
You're meant to embrace the knowledge of your peers.
Well, it depends what the knowledge is, I suppose.
Yeah, but Bandy, if I came to you and said, could you teach me how to fit plumbing to a sink?
Yes.
You'd be able to tell me because of your expertise, right?
I hope so, yes.
Yeah.
Yes.
But that would be the same as you coming to me saying, can you show me how to do a fillet weld?
Mm-hmm.
And I'd turn around and go, yeah, you're left or right-handed. Because I hate showing lefties.
Oh, okay.
Well, I had to teach myself how to weld left-handed, and that's it's freaking backwards.
Yeah, having to learn to do something left-handed so you can teach left-handers is a nightmare.
Well, I actually had to teach it so I could get into a certain position that I couldn't reach with my right hand.
All right. Well, we need to get back to reality. This atmospheric pressure.
Bandy?
Yes?
Do I have to explain it again?
Possibly.
Right. Now, I'm glad you asked. What is a container?
It's a receptacle.
No, a receptacle is something with an open top.
Yeah, that's a container.
Not in engineering, it's not.
Okay, then.
It'd be classified as a receptacle or a tank.
Okay, then.
Okay.
All right.
But a tanker, such as one that holds petrol or milk or LPG, is a sealed container.
Exactly. And what can you do with a sealed container? You can increase the pressure.
Yeah,
Because it's in a container.
But here's the funny thing, right? those particular tanks are designed to hold something in, not hold something out.
Yes, exactly.
Yeah, I mean, you want to look at the dive cylinders I've got.
Yeah.
Bloody, and they're old-fashioned steel ones. Bloody hell, do they weigh a ton?
Exactly.
Yeah, but if you decrease the pressure inside that tank, it would squash. But the amount of
because
pressure,
they're not designed to be squished. They're designed to be blown
pushed
from the inside out.
Yeah, Bandy's favourite word. It's a pushing force.
Mm-hmm.
Yes.
Okay, the amount of
Don't
pressure
squish
you
them,
have
though.
to, but the amount of pressure you have to put inside even a tanker is massive for it to pop.
Yeah, although I think actually, given that my tanks hold 3,000 psi, I think reducing the outside pressure by 14.7 psi isn't going to have much of an effect on the tank.
Yeah, well, that's why I used a petrol tanker, because you've got a
Oh,
greater
yeah, because they're
surface
not
area. Yeah,
and they are not designed to be. A petrol tanker isn't really designed to be pressurized anyway.
no,
In either direction.
no, but it is a sealed container
Indeed.
because it
But
doesn't
you
want
don't want the
any of
petrol
the.
evaporating out of it, do you?
You don't want the fumes escaping. You don't want evaporation to happen, because if you've got less fuel than you're prepared to give to the petrol station, you're going to get in trouble.
Yeah.
Okay, so this is a container.
Yes.
Right? The moment you take a top off of a container, it is no longer containing anything.
No.
Containment means to retard something from going anywhere.
Mm-hmm.
Mm-hmm.
Yes.
Right. So if I had a fish tank, okay, it's got an open top.
Most do, yes.
Water can evaporate out of it.
Mm-hmm.
Mm-hmm. But technically, it's not containing that water vapor.
No, the water vapor, it's not.
No. So therefore, if it's got a hole in it, it can't be a container.
You're actually using different words for the different explanations of what you're actually saying.
It's not a sealed container. It's an open container.
That's why it's classified as a receptacle, because it can receive it, but but if you tip it, it won't stay in it.
Yes.
They keep getting confused with the word contain and container.
Yeah. Okay, you can call a bucket a container.
Right,
but
because
it will not
contain a liquid or
a mass
or anything.
It can contain a mass,
Mm-hmm.
but it will not constrain that mass. See, it's another word that they seem to miss. Okay,
Yeah,
containment.
and let's face it.
Yeah. Go on, Alan.
A bucket only contains a liquid because there is also another force being applied to the liquid.
Yeah.
The buckets only work near this big great thing called the Earth for holding things like water. If you were to put the bucket, I don't know, a long way away from the Earth, things would become a little more interesting with buckets because they wouldn't really work very well, because there'd be nothing to stop the liquid leaving through the open hole.
If you have a fish tank that has nothing but air in it,
yeah,
and you measure that,
yeah,
the pressure in that fish tank.
Yep, it'll be the same inside as it is outside.
Exactly right. Now you get a compressor, right?
Mm-hmm.
And you blow some more into that fish tank, bit more air into it.
It won't hold it.
Won't hold it, will it? No, you can't. You can't increase the pressure, can you?
Nope.
No, you can't.
That's right.
Exactly.
Because there's no lid.
Yeah, that's right.
Yeah.
My point.
Yeah, but that's
No lid, no pressure. Exactly.
Yeah, but it's already got the atmosphere.
Yeah, but it's like.
But it's already got a measurement.
So you're saying it's a force field? Gravity's a force field. Is that what you're saying?
You can't say that.
Well, it's got to be a force field of some sort if it's containing it.
No, it's just accelerating it it's just accelerating it all down to the bottom of the bucket.
Yeah, gravity is an accelerating force.
Well, what about the?
Well, actually, I like to think of it as an acceleration, which we can derive the force from by knowing the mass of the mass of whatever is being accelerated.
Yeah, well, even Newton said that gravity is the force of the acceleration towards the planet.
Yep.
Right. So unless you have a heavier gas, you cannot increase the pressure inside the fish tank.
That's right. Yes.
Okay. But the pressure in the tank is already at 14.7 or 14.69 something.
Yeah, 487.
Yeah. But you can increase the pressure on the inside of the tank by adding water.
Mm-hmm. You can.
But the mass of that water is not enough to blow the tank out.
Mm. Depends on the size of the tank and how much water and how thin the walls are.
Yeah, but that's all variables. But I'm sure they've been making fish tanks for long enough that they sort of know what they're doing.
Well, you hope.
Yeah.
Yeah. You would hope so. The other thing too is, and I said this to you the other night, if we were inside a dome, a contained field, the amount of off-gassing that everything on the planet does would increase the pressure. Because do you think we suck in all the oxygen that the plants give off?
No, because I don't give off enough oxygen. It comes mostly from the algae.
Yeah, well, do you think we suck up all the oxygen that comes from that algae?
No.
Right.
Maybe
and do you think all that algae and all those plants take in all the carbon dioxide that we breathe out?
No.
Yeah, it goes into the sky. But if there was something stopping it from getting out of the atmosphere, it would increase the amount of those molecules that have mass would increase within the atmosphere that is held inside that dome.
Maybe. If there's a dome, I don't know.
But it will. And actually, I'll bring in entropy here. If there's nowhere for it to entropy away, the mass increases.
Well, yeah, it doesn't make logical sense though.
But that's how that's how the law of thermodynamics works. If there's nowhere for the energy to go, it increases the mass. So by those particles escaping out into space, that's the entropy of the planet.
I'm getting really tired, guys.
Well, I am finishing up anyway, Bandy.
Yeah.
I want to thank everyone for hanging out for this short one that we sorted out the technical issue, and hopefully I'll keep using what I'm using now until I can sort something out. So we'll see you in the next one.
Yeah, thank you, Terry.
Thanks, Terry.
Night all.
Very interesting. Bye, chat.
Bye, chat.
Bye, everyone.